yesterday was a relatively easy day. We've been solving like easy medium problems. So today is going to be hard. So today we're taking the most complex problems in the workshop. So if you can't understand the problem on the first time, so I'll try to be as slow as possible, and we'll continue where we stopped yesterday. So the next problem is called toast, and I hope your ID is ready, so your keyboards are ready. So let's kick off the workshop. All right, so our next problem is toast. So the toast component is basically the component that displays some informative text like this. So our goal is to build the component that is able to toast the message. So the message itself is very simple, it's just a text. And then we can also set the duration, how much the element should live here. So as you can see, we have the fade in animation when the toast appears, and also the fade out operation. And once the fade out animation is completed, we're kind of removing the element from the queue. So that will be our goal for this problem. Before we start, let's discuss the solution approach that we want to take here. So first of all, we need to understand how can we detect when the element should be removed. So for this type of problem, we're going to use the animation end event. So essentially, when we play the fade out animation, we're going to catch this event when it's ended. So this means that the element is not displayed, and we can safely remove it from the DOM. From the accessibility perspective, we're going to use the role status, which tells the screen reader that's the status update, and we're also going to use the area live, so when the element appears, the user can get the notification that there is a toast message on the screen. So the data shape for the toast is super easy. It's just ID and the text. So that's what we use for the input data. And in order to solve this problem, first we'll define our property model. So this is the first step. We'll be defining the types. Second one, we'll create the so-called the template, or if you're solving in React, it's going to be JSX. Then we expose the API to the external for the external developers, or in this case, example that's showing the toast. And then we're going to handle the events. In this case, it's animation end event, so we can safely remove element from the DOM. And the last step, once we handle the event, we can just clean up the DOM from the remaining elements, and that will be our strategy. All right, in terms of how to use the component, we're going to build this component in vanilla TypeScript. So this component will be initiated as a simple new class. So with the root element where we're going to append the toast messages. And here, how can you toast the message? You just basically call component.toast, and this will be your, and the message will be toasted. Okay. In terms of the types are super easy. By default, we're going to use the timer, the timer constant, which will be 3,000 milliseconds. So our toast message will be alive for basically for 3 seconds. And the single toast item is just ID and text. And in terms of how we're going to handle the animation event, so here's the logic. Imagine that you have the toast list and it has the state with the following item. So the item 1 is appeared on the screen, and by default it will have the status removed false. This means that this item should stay on the screen for now. So now the fade in animation starts, and we show like this we show the toast message. When the fade in animation ends, we're going to execute the event listener to schedule the callback to remove the element. So now we're marking the element to be removed. So this just tells us that, okay, once the fade out animation is completed, we need to take this element and remove it from the state. So now the fade out animation plays. We wait for animation end event on the fade out. and then we remove the element from the state. That's the solution that we're going to take in this problem. Okay, so let's jump to the code now. Open the let me tell you, 38 toast folder in your IDE, and let's start solving this. Okay, so first of all, each toast will have the ID. So by default, if ID is not provided, then we can generate the ID for the static variable. So we'll just create a static instance of toast instance ID. And if ID is not set, then we'll just initialize the ID by default. Also, we have the list element. It's basically where we're going to append all the toasts, because we have the container, which will be an ordered list, and each list item will be our toast message. And then we have the main container, where we append our elements. Okay, so in the constructor, we pass the animation end event, so we can track once the animation is ended, we're going to render the toast element. So in terms of template, we're starting with a simple predefined template, which is basically the unordered list, where we will add all our toast elements. Here, you'll see we already provided some area elements. So this one, area live polite, and area relevant. So what it does, so when we add or remove elements from this container, so the screen reader will automatically pick up these changes and will report to user that this element was removed or this element was added. That's why we're adding this accessibility attributes. And also we set up the toast instance ID. So here each toast component will have its own instance ID defined here. Okay, so for now, this component doesn't do anything. So first of all, it would be great to actually render the toast itself. So let's create the toast function, which will be exposed to the user of our components. And this toast function will accept the toast item. Okay, so now what we need to do, we need to create our toast element. So let's create also the function that will generate the toast element. So in this case, it's going to be get toast item. And then it will accept the item. And then we need to return the template of the toast element. So in the template will be super easy. It's going to be just a Li element with a role status. And inside, we can place the content. So for instance, we can have the paragraph and then place the item to text. So what else? Once we also can assign the unique ID, which will be our item ID. Okay, and now we discussed that each toast element can have a status. Removed or not removed. This will be needed to then later understand if the element should be removed from the DOM. So this data attribute we're going to access from the event object when the event is fired. So by default, this will be equal to false, but later and set it to true. And okay. So now we can create a toast element. So let's create an element called toast element. And then we use the document create element. This can be just a simple div. And then we update the HTML of the toast item. And then just pass this get toast item. So the element that we created here is basically just a wrapper element. To get the real toast element, we need to access our wrapper. So let's create a constant called element, and then access wrapper, and first element child. This will give us the toast element that we just created here, the Lee item. Okay. So now we have the element. This element now should be appeared on the DOM. So once we toast it, it should immediately appear on the DOM. So we access our list element, and then we use the append child to append the element. Okay. So, and once the element is appended, we need to immediately play the animation. So this means we access the class list. And then we need to use the fade in animation. So in terms of animations, if you open the toast module.css, there is already fade in and fade out class, so you don't need to worry about this. And also our toast has some very basic default styles, so we just use the default styles to save our time. And we can apply these classes now. So first of all, let's apply the class to the toast item itself. So here, we use a css.toast. And now we apply the css.fadeIn class name. Okay, so if I try to load now, this will not work because the list element right now as a reference is null. So let's make sure we also initialize it. So after render, so once we rendered the component, let's initialize the reference. So this acts like a React reference in this case. So list element, and then we can query our container. Then we can use query selector. And then, actually, because the toast has ID, we can just use the ID instead. So yes, this is the toast instance ID that we can utilize. So instead, let's go, let me hide it. Document get element by ID, and then we pass our instance ID. So this should pre-initialize the list element. So TypeScript now is complaining, but so I put the exclamation mark here just to tell TypeScript this element is not null. And also it is complaining that the list element should be HTML unordered list, so we can cast it as well. So I think it accepts the generic, so we can use it like this, HTML unordered list element. Oops. No, it actually doesn't accept the generic, sorry. So we'll have to cast it like that, as cool. I noticed one thing. I don't think we need the container here, so let's remove it, because container is already initialized by the component, by abstract component. Good. So now, if we try to render this, so let's open our website. Refresh the page. So let's see why it's complaining. Oh, it's because we haven't defined on animation end. Yes, that's correct. Let's provide on animation end event handler, and then now it should run. Okay. So here's our example. When I click on the toast, it should appear on the screen. And as you can see now, the toast appears on the screen, but it will not disappear because we don't do any cleanups right now. So let's fix this one. Here, when we toast an element, we now need to schedule the removal callback. So for this, we're going to set the timeout. And then our timeout will be the timer timeout constant, which is 3000 milliseconds. Sorry, what's the name of this? Oh, we don't have one. So let's create one. So it will be timeout 3 seconds. And then we pass it here. And once the timeout is passed, we need to take this to take the element which we added, and then remove the old fade-in class name. So we access the class list, remove fade-in class. Then we're gonna add the fade-out class so we can gracefully disappear the element. Remove, fade out. And in order to catch so once we catch the animation end event here, we need to detect if the element can be removed. So for this, we set our data property. So we access the data set dot removed, and then we set just true. Okay.
It's line 65 should not be removed.
It should be removed. Yeah. Thank you. Okay. Now the element should be marked as removed once the timeout plays. Let's test this out. So it will still not so technically the element itself will disappear because we play the timeout animation, but it will not be cleaned up from the DOM. So let's see what is happening here. So this will be our future list with all, and let's set our elements. So the class hasn't been added as I see, so let's check but the removed was set. So see, now the element should be removed technically, but for some reason our animation hasn't played. Yeah. Oh, it's because we haven't added this animation. Yeah. So let's fix this, refresh the page. So now our elements are getting removed, but they're not fully removed. So if we check the DOM, they're actually still here. It's just the animation just made them invisible. So our next step will be to clean up the DOM. So in order to clean up the DOM, we're going to listen for the animation end event. So this event has the target. So basically the target will be the element on which the animation event was played. So, and we check if target instance of HTML element, and also if the target dataset removed equals to true, then what we do, we just basically remove the element from the DOM. That's it. All right, so let's see if it works. So refresh the page. Let's output the elements, but first, let's access our list. So see, now the elements are automatically removed. So we've completed the toast. Congratulations.
How come you don't do the toast, do the remove in the set timeout after it fades away?
Oh, you mean like why we do not remove it here in the set timeout?
From the DOM, yeah.
It's because when you set the time, so first you need to set the class, and then when you add the fade out animation, so you cannot track how much it will take the fade out animation. So you will need to set another timer to kind of verify that fade out animation is ended, but it's very hard. So we track the browser event to get the animation done, because the animation itself will be played. So based on the device performance, it may take kind of milliseconds longer or less to play the actual animation. So you can't really truly understand what's the time, and you will face the situation where your elements will be removed, and the animation was still playing. That's the thing.
Okay.
Okay, so let's jump to the slides. Do we have any questions in the chat?
Not a question, but something I was going to ask before we started. Do you think, are you still able to use WebStorm if you turn off the inlay, what do they call the inlay hints? I was wondering if like there was a suggestion yesterday at turning off the inlay hints that would like reduce the line length of some of the functions and keep more
Okay,
on screen.
how do I turn it off?
That suggests, I think there's, if you, let's see, to disable the hints that are currently in your editor, right-click. Yeah, right-click on one of the hints. I think if you actually right-click on like one of the hints, like the
Element.
like where it says.
No, it's on settings. You can search for inlay hints and then use a checkbox and then.
Oh yeah, yeah.
Okay. So it's called
Inlay.
Inlay hints.
Inlay hints. Okay. Let's disable.
Yeah, let's see if it throws you off. I wonder if you have to. Yeah, so it looks like they're.
Okay.
Yeah, that way we're only going to see the types that you add and it won't and the function definitions won't have the thing there. Okay, perfect. Thank you. And let's see. And no other questions. So moving on.
So just a recap. So we define the template item. Then we assign the list element to our instance so we can populate new items inside. And when we use the toast, we created the element, appended the child to the list element, then scheduled the removal, removed the fade in class, and added the fade out, and then marked the element ready for removal. And then we scheduled an animation end event to track the when the animation fade out animation ends, and then we remove the element. So this problem is not hard code-wise, but it's not too obvious to come up with listening to animation end event for the cleanup. Okay, so next we have our favorite TypeScript challenges. I know people love them, so let's move on to our IDE. So our next TypeScript challenge called capitalize. So the idea here, you pass the string, and then within the string you capitalize the first letter and generate a new type. So that's the idea. Let's jump to the code. Let's open the capitalize challenge. And here we have a bunch of test cases, and let's implement this. So we take our type called myCapitalize, and then it accepts the string. And in order to force the type checker, to force this variable to be a string, we use extends string. So you cannot pass anything except the string. And now we're going to do the pattern matching within the TypeScript. So apparently you can use the extends keyword to match the string. So in this case, you can do the following. You can say, hey TypeScript, can I get the first letter of the string? and then and then the rest I don't care. So here we're asking TypeScript to kind of get us the first letter. So let me put it on the next line so you can see it. And if the string matches this pattern where we have the first letter defined and the rest of we have the rest of the string, then we can say we can construct a new type by taking our first element and then the rest element. But the thing is, we need to capitalize the first letter. So for this, TypeScript have utility type called uppercase, and then we just uppercase the first letter. Otherwise, we just return never. Let's return just S. Yeah, that's it. Now all our test cases passes. And I guess there will be some questions on this challenge. Do we have anything in the comments? Yeah, TypeScript, lots of fun.
Would it be possible to not infer and just pattern match it?
To not infer, just, yeah. So you can just use string. So basically you are saying there should be some string here, and you can also match it like this. So you can say, I want to match the string, so there is a string before, string after, and some number in the middle. You can do it as well in TypeScript. So this acts like a regular expression matching in this case for the string.
Got a cool trick and a wow in the chat for there.
Okay, so we have one more challenge on the strings. So the next one is called trim left. So at the beginning, we have the spaces like this, and then we have our hello world. So we want to trim the spaces on the left side. So it's a similar thing for us to solve. So let's go back to our IDE, open the trim challenge, and first let's define our type space, which will be just empty space like this. And as you can see, our test cases also have the new line separator and also the tab symbol. So let's also handle this. We'll create a separate type that will have the tab symbol, and we'll also have the new line symbol. Cool. And now what we need to do, we need to define the trim left. And then we should force the TypeScript to limit the generic to be just a string. And then we follow the similar pattern. So what we need to check if there is a space at the beginning. So the way we're going to do this, we're basically asking the TypeScript to pattern match the string. So we are saying, hey, TypeScript, if the string has the space at the beginning, and then we have the rest of the string, then what we do, we just return the rest of the string. And because we're just removing one space, this means that we need to enter the recursion and run the trim left again on the rest. Otherwise, just return S. Yep, that's it. And now we get our trim left function implemented.
Would this work with any Unicode character?
Yep. All right. If we don't have any questions, we're going to jump to the next problem.
So it extends space.
Congratulations, we've completed the easy part of the workshop. So now we're entering the area of advanced components. So these components will take more time to implement, and you will see that I might be able to do more mistakes now. So in the code, so that's expected. The components will be quite complex, and we'll use multiple patterns to implement them. And if you cannot solve it in the first attempt, don't worry. Just watch the workshop and the recording later and go through the problem yourself. So our first component that we have is calculator. So we're going to implement the calculator, which will look like this. So we have all our function buttons, and then you can write an easy formula and execute this. So there will be no algorithms here. So for calculating the formula, we're not going to use any Polish notation and all of that. So it will be a very easy eval. But in order to implement all these functions, we're going to use the modular pattern. So we can define each button as a separate component and then construct our calculator from the buttons. Okay. So in order to implement this problem, first we'll define kind of a simple layout. So as you can see, the top element, it will be our output. The HTML have the special tag called output, which you can use for outputting some data. So and then we have the input grid. So we're going to use the CSS grid in this case. So where each element will be the grid item. So we'll set up the grid in a way that we have 4 columns, and then the new button will just automatically take place based on the ordering within the buttons array that we pass. Then every button will define an action, and this action will take the state and will act as a mutation for the state. So, and it will produce a new state. That's basically a very Redux approach, where we have an action that takes the state and we generate a new state. So similar pattern here. Treat each button as an action. And first we'll define all our actions. Then we'll add the component properties. Then we'll render the UI. And then we handle all the handlers. Okay. So let's start implementing all the actions first. What are the actions that we have on our calculator? Let's jump back to the IDE and open the folder 41 called calculator. And there is a folder called utils. Here, we already have some scaffolding set up. So for instance, we already defined how our action button looks like. So it takes the state, it takes the operator, and then it returns a new string. That's what every button action will do. So the next thing is how our calculator button would look like. So the single button will have a label, which we display on the UI, and then we have an action that will be executed. Also, if we have some invalid value, for instance, if you try to divide by 0, then we'll need to use the invalid value constant to set it. And then we have a set of the operators. It's just plus, minus, multiply, modulo, and the division. Okay, so also we have the utility function that we don't need to care about. This function just basically strips the number and ensures that always have the precision point that we define. In this case, we set up the 5 precision point to the number, and it also removes the backward the zeros from the number at the end on a floating point. That's it. That's our scaffolding. So now let's start implementing the actions. What is the most easiest action to implement? It's actually to just add the number to the string. So let's check it. So the logic here, if we always start from 0, and if we click on any calculator button, so here, we need to update it to the number that we are selecting. And then if the number is not 0, we just append in the new number here. So let's implement this. So what we do, if the state equals to 0, Then we're going to return the number. Otherwise, we're going to concatenate the state with the number. Okay. And now we can run a few tests. Here we have some console logs. So if we use the 0, then it should output 5. And if we have already 12, and we add in the 3, then it should be 1 to 3. And the floating point should be added to the number as well. So let's run the test and see the output and see all the outputs added. So the first action is done. Now let's complete another action, which is the applying the operator. So the logic here, if our formula, so for instance you have 5 plus, already has a leading operator, this means that we just need to replace the operator again for another one to avoid having the situation where we add in multiple operators at the front. And yeah, that's the logic. So first we get the first we check if let's fix the naming, and if the state starts with ends with we have the operators array, sorry. So we need to check if the last letter is the operator. So for this, state, and then we use the at function -1 to get the last letter at the string. Okay, so now we're checking if the state has the if the last letter is the operator. In this case, we return the so we calculate the result. So we are slicing our state. Slice, and then we basically want to cut only one symbol at the end. I think we can just do this with -1, like this. And then we return a result with the operator that we are providing as a new one. Otherwise, we just merge the state with the operator. Okay, so let's test this and see if it works. So in case of 5, it should add the plus at the end. In case of 5 plus, it should replace the plus operator with multiplication. So let's run the test. And it's incorrect. So I think the slicing doesn't work properly because we need to provide let's provide 0 as the first position and -1 would be the last position. So let's recalculate. Yeah, now it works. Good. So now we have another operator implemented. So let's continue implementing our operators. So the next one is called clear. So this one is easy. You just need to reset the whole string. So in this case, what we do, we just return 0. That's it. And I think we can skip testing this one. And also now we have another operator, which is calculate. So what it does, it takes the overall formula and basically executing this. And in order to execute this, we need to construct the expression and create the function, and then execute this function. So, and now I'll show you how it looks like. So here we get the raw result. And let's call the new function. And then we pass inside the what we want to execute. Here is going to be return state. So here we are forcing JavaScript to evaluate this. And I know it's not super safe because the state can be anything. It can be some JavaScript statements and so on. But because we're working with a calculator, and the data comes from the elements that we define and the actions we define. This kind of sounds safe, but it's still in the real world application. You still want to sanitize your input. And now, in order to get the raw value, we want to execute the function. So we wrap it in the brackets and then just execute it. So now we get the raw value. And then we check if number is none, or number not finite. So not finite means that we get infinity as a value, which is kind of invalid value in our case. Then we return invalid value as a result. Otherwise, we just return the raw value. Okay, so now we have the calculate implemented. So then let's review all our actions. The last one that we haven't implemented is called negation. So essentially, the negate works like this. So let's move it to the negate. You have the number, and then you use the negate operator to negate the whole expression. And then you can negate it back by removing the minus. So the operation itself is relatively easy. We need to first we need to check if we already negated the value. Then we need to remove the minus with the brackets. Otherwise, we just wrap it with the brackets and the minus. So let's check it. If the state starts with the minus and the bracket, and state ends with bracket, okay. Then we can just return the state and slice it. So first we slice 2 symbols at the front and then 1 symbol at the end. And TypeScript is complaining here. Okay, we're missing 1 bracket. Otherwise, we return the state. With the brackets and the minus. And let's see how it works. So let's take our console logs and run it. See, and that's the expected result from the negate operation. Good. Now we have all our actions defined. So, and to make our calculator extendable, we can define a set of action as a map. And then we can import this map to our calculator component and render it there. So the developer of the calculator, they can extend this component with any button. So because you can implement more actions if you want. So, oops, sorry. In order to do this, so now we need to define, we basically need to set the action to every element here. So for the AC, the action is going to be clear. For the plus minus, the action going to be negate. And one thing here, our actions, let's make sure that our actions have this the same signature, so it should not be an issue. Okay, so clear, negate. Here we have the apply operation. So let's remove it. Apply Same thing here. So we're applying the operation on the multiply. We also apply operation. On the minus, we apply operation. Equals, we call calculate. And on the plus, we also apply operation. So do we miss any? Have we missed anything or not? I think
Just some brackets at the end of apply operation in the middle.
at the end of apply operation in the middle. Yep. Here. Okay. So I think we're also missing a few brackets here. That's why the TypeScript is complaining. And the rest, we need to change this. The rest of the functions should be changed to the apply number.
Like line 119 needs a bracket too.
119 is bracket, yes. Good, cool. So let's replace that. So I'm gonna use the multi-line selection, and it doesn't work. Okay. Okay, let's do it manually. I forgot the shortcut. Use the apply number. And then just add this here. Now TypeScript is happy. Let's quickly verify. So the AC has a clear, plus minus has a negate, apply operation. So this is apply number, looks correct to me. So now we have all our actions and the buttons. We can now actually implement the calculator itself. And with the calculator problem, I think the main thing here is not to overcomplicate. What we can, because we're already going to use the CSS grid, it will be so much easier to implement all the things. So for this, let's have our calculator defined as a section, and it will be our grid element. So we apply the class name, CSS calculator. So the calculator styles are not defined, so we're going to define them just in a few moments. And let's render all our buttons. So we're importing our buttons here, and we can just basically iterate over them. So our buttons, and because our buttons are static, so this means that they don't really change, we can actually map them like that. So buttons, and then we're going to use entries, map. Actually, we probably can just use values. Values buttons dot map. And then we can map each button to the button itself. So we're going to return the button. And inside the button, we're going to have our label. Okay, so for now, and let's also assign the data attribute called data operator. And then the button will have, let's remember the property that we're setting. So it has basically the operator matches the label. So let's get back and use the label as an operator. Okay. And the key can also be the label. So let's put our buttons here in a section. And before also we do this, let's also have the output section where we output the current state. And for now, it's going to be just 0. So let's create a state. Set state and use state equals to 0. And then we output the state here. Good. Let's see what we've got on the web application. So let's open the page. Let's open the calculator component, React implementation. Let's refresh the page. And nothing's here. Let's see why it's haven't rendered. So the buttons should be here. Object values, map. Let's see if the buttons are initialized. Log buttons. Refresh. So the buttons are empty array. So let's, oh, I see. Because the buttons is already a map, we cannot do this. So we need to call the buttons values. Yeah. Okay, now we have our beautiful calculator done. So let's do some basic styling to make sure it actually looks like calculator. So here, in order to simplify the whole layout, we're going to define the CSS grid. So let's get back to the calculator module CSS and define our calculator class. And then we're going to use display grid. Then we're going to use the grid template columns. And remember, we said that we want to have 4 columns. So we're going to use the repeat function called for. And let's make each column to equal maybe 100 pixels. And then we can use the grid auto browse and then call 100 pixels. So now I think we should have something similar to calculator. Yeah, now we have all our stuff done just with 2 lines of code. So see, now the output element is kind of on the left because it's the first element. But the cool thing about CSS grid, we can scale this element on 4 columns, and it's super easy. So what we can say, we can use the calculator output, and then say that the output will take grid column 1, 4. So from first to the 4th column. And if we refresh the page, probably should be 5 then. So now our output element here. And let's make it a bit more nicer. Let's apply the border. 1 pixel, solid black. And the background, maybe something like this. So if we refresh, here's our calculator. And let's also apply the border to the calculator itself. Border, 4 pixels, solid black. Refresh. And as you can see, our section takes actually more. So our section spans across the whole page. So what we can do here, we can just say width feed content to make sure that it doesn't take more space than it's needed. And that's done. Now we have our calculator set up. Okay, so here the 0 element, it's kind of looks weird. Let's also fix that real quick. So we're taking our output and say that the font size should be, let's set it like 3 rem. And also let's use the flexbox to align the the element itself, flex, justify content, flex end, and then we align the element in the middle of the row itself. So let's see how it looks. Okay, and let's maybe add a little bit of padding, maybe 2 rem. Yeah, let's do 1 rem. Cool. So now the UI is ready. Here's our calculator. So the remaining bit is to handle the events. Here I'm going to teach you, I think we've already done it multiple times, but when you work with many elements, you have always an option to use the event delegation as a pattern. So instead of applying the action for every button here, so you can register the event listener at the top, for instance, on a section element. And in this case, you just register one event instead of like registering 20. And the main performance gains that you get is when you have hundreds of elements. So if you, instead of creating 100 functions, you'll just have one. And if you have a large app, it actually significantly impacts the RAM size that your application takes. Okay, so let's create a function called handle button click. And this will be just a React mouse event handler. And then we get our target. And now let's define the logic. So what we need to check if this if we have the data operator existing on the HTML element and if the target is the HTML element. If target instance of HTML element, then we get the, and we also need to check that the action exists. So target, dataset, operator. Then we get our operator. And we get the buttons map that we already receive, and we get an action. So we use buttons get operator, and if button exists, then we set state. We take the current state, and then call the button action state operator. So, and that should provide us with a new state. Now we register this event listener on the top level element. This, as I said, this is called event delegation. And let's see. So let's try to see, add the elements. Let's reset. Let's also do the plus, oh, it's actually plus minus, sorry, 5 multiplied by 5 plus 1 negate equals minus 26. So all the basic calculator stuff is here. Maybe like this. And that's it for the calculator problem. Any questions on this one?
Just kind of a general one. You've done a good job in the repo kind of indicating on each problem how long it should take. So for example, this was like a 25 to 30 minute problem. In an interview, how much time would you have to plan, or would it just be implementing, at the time that you're given?
So it depends on the company. So some companies say that we have 1 hour in a coding interview. So usually it's like 10 minutes on introduction and 15 minutes coding round. So if you're interviewing for the staff roles, most likely your coding round will be like 2 hours because you're going to get more complex problem.
And planning kind of factors into that time that they're allotting you, right? For you to kind of like plan how to do it too.
Oh, so if you have the 50 minutes, so at the beginning we had our general plan, 2-3 minutes on understanding the problem, and then maybe another 2-3 minutes to discuss the potential solution. And if you have multiple solutions, discuss it with your interviewer. And once you propose your solution and the interviewer agreed that it's the right way to go, so you start implementing the solution. You should leave maybe 5 minutes at the end to make sure you have enough time to test some basic cases and if it works. So, and remember on interview, especially with the component problems, so you as a candidate, you shouldn't implement like 100% bulletproof solution. So as long as it works for maybe 70-80% test cases, and it just it's already has all the functionality, it doesn't matter if you have a mistake a little mistake somewhere. So this is the component design. So many things can go wrong throughout the interview. So it's not like lead code style problem where you have the specific algorithm that you need to build a specific and yeah, all the component problems, they're open-ended in this case. Good.
Actually, hang on. I think there's one more. While more performant, this event delegation feels unexpected. Would you only reach for it if discussion drifted to performance, or if explicitly requested to do it this way?
So it's actually up to you. So if I don't think that interviewer will spot this thing, because what I've noticed that not many people know about the event delegation technique. So, and it will be definitely a plus if you mention this, because that's actually the way how you handle the in the large apps the events. So for instance, in a Google Sheet problem, we'll have around 2,000 elements. So, and if you register the event listener on each of these 2,000 elements, you will get the heap size around 100 megabytes. So you can basically cut the heap size by 100 megabytes just by registering a single event. So yeah, that's the thing. So it's more like expert technique that good to know. Not everyone knows, and it definitely will be a huge plus if you demonstrate this on the interview. Personally, when I bring this on my interviews, people just like, wow, what's that? Like, not everyone knows it. Shall we continue?
Let's move on.
All
Actually,
right.
you know what? We're due for a tech break, so maybe we take this as a chance to do a 5-minute break quick.
Yeah,
and then
sounds good.
And we'll come back. See y'all in a bit.
Or hard problems. So the next one is called 8 puzzle game. So the idea of the 8 puzzle game, you have the numbers from 1 to 8, and you have an empty square. And the way it works is essentially that you need to rearrange your squares so they will be in order. So for instance, in this case, I just need to move 8 here, and then all my squares are rearranged, and the game status is win. So you can move this empty space in up direction, left, and right. So as you can see, we're just exchanging the square with the neighboring cells. So that's the problem. So the main challenge here is actually implement the validation. So how can you move the cell up, down, left, and right, and also generating the game state and some basic layout techniques. So you can go as complex as you want. So for instance, if you try to implement it with a flexbox, it's going to be a bit harder you will need to write a bit more CSS. Here again, we're going to use the CSS grid to do this. So let's jump into the problem. And actually, before we jump to the problem, let's review how we're going to solve it. So first of all, imagine that we have a game field. This will be our CSS grid. Then we'll define a CSS grid as 3 rows, 3 columns layout, and then we pre-generate a state where with the empty cell. So one empty cell will be just a null, and our state would look like this in this case. So the first row is 1, 2, 3. Second row is 4, null, 5, and the last row is 6, 7, 8. And we can move the empty cell and exchange the values in these rows. And the win condition is when all the cells are in order from 1 to 8, and the empty cell is the right bottom corner. So, and as you can see, our game state will be actually 2D array. And in order to solve this, so first we'll create an array, then we'll randomize it, then we will convert this to the 2D array in order to create our field. Then we'll introduce the state validation, and if the move is valid on the click, we'll allow exchanging the cells. And if it's the win condition, so we check the state. If it's if the player win, then we show the status and update it. Also, we will need to handle the clicks. We're gonna use the event delegation technique to handle it at the top level, and we'll provide the rendering function for our component. Good. So let's first start with building the game engine. So let's go back to our IDE, open the Square game, React. So most of the problems we're going to use React for the rest of the workshop. So the game size by default will be equal to 3. So here's the expected data that we should have inside our game state. So our first function that we want to implement is actually creating this game state. So let's do this. So let's create a function called create game state. And what it does, it returns the array of a number. And because we can also have the null, it will also have a null value as well. Okay, now we need to generate an array from 0 to 9, because we have in total 9 elements. So for that, let's create a variable called state. And then we're going to use the array from. We'll pass the array-like object in order to initiate the array. So, and set the length to the game size in square. So this will generate the array of 9 elements. And then we'll remap each value. So because we don't have any value set, we just use the index. And if index equals to the game size multiplied by 2, which means that it's the last index. So we also need to subtract 1. Then we return null. And for the rest, we just use index plus 1, because the index starts from 0 and our game field is actually 1 to 8. So that's how we create the state. So apart from that, we need to randomize our state. So in order to do this, we can apply a very simple technique. We take the state, use the sort, and then we use the math random, and math random generates the number from 0 to 1, and then we can subtract 0 to 0.5. This can almost randomly give us the -1 or +1, so which will kind of randomize our array. And we do not assign the state here because the sort is mutating operation, so we will already mutate the state. Cool. Now we want to convert our array into the 2D array. So for this, we need to kind of chunkify it. In order to do this, we're gonna take our state, actually, yeah, no, we're gonna create a new array with the length. So because we need to have 3 rows, so we use just the 3 rows array, which is the game size. Game size. And then we're going to remap this array. So now we have indexes from 0 to 2. And then we can slice our state into the chunks. So we use the state, slice, and then we use the index multiplied game size, and index plus 1 multiplied by the game size. So what this function does, it essentially chunkifies our initial state. So for instance, so the index will be from 0 to 2. So if the index is 0, it will slice the initial state into the elements of 0 to 2, so 3 elements in total. And then if the index is 1, then we take the elements from 3 to 6. And if the index is 2, we take the elements from 6 to 9. That's how we chunkify the state and convert it into a 2D array. OK, so now we have our game state. Let's also create a function that validates if the game state is the win condition. So for this, we create a function called isWin. And it accepts the state, which is our 2D array. And then we need to flat the state. So we use the function called flat to convert our 2D array into the 1D array. And then we need to verify that every value is in order. So we take our value and the index, and essentially we can check if every value is in order if the value is equals to index plus 1. So we start with a 0 index, so the first value should equals to 1, and with, if it's the second index, then the second values should be equals to 2, and the last index should be equals to null. That's the win state. So let's check if index equals to game size square minus 1, which is the last element, then, and the value let's maybe convert it to the full function to make it easier. So if value equals to null, then the index should equal to game size square minus 1. Otherwise, we just check if the value is equals to index plus 1. This is our isWin function. Any questions on the game state and isWin function before we jump on? If not, let's create another function. So the last part of the engine is to validate if the moves are valid. So we can remember that we can move our cell up, down, left, and right. So we need to validate if we can move the cell horizontally and vertically. So for this, let's create a function called validate. And this function will take the two coordinates, x and y, so x1 and y1, x2 and y2. So basically, the first coordinate it's what we are moving, and the second coordinate where we are moving this element. So let's define our tuple. So the first set of coordinates will be xy, which is number, and then another set of coordinates will be x2, y2, which will be number. Okay, so now we need to validate if we can move the element vertically or horizontally. So let's first check if we can move it vertically. So if is valid vertically. And in order to understand if the move is valid, so we have two basic conditions. So first of all, the y2. So the x1 should be equals to x2. So this validates that it's not a horizontal move. And is valid horizontal move. So we validate that y1 equals to y2. And one missing piece, we can only move to the +1 coordinate. So this means that we need to check that y1 equals to y2 minus 1, or y1 equals to y2 plus 1. So that's basically up and down. Same thing here. So let's copy this and instead replace it with x. And then if at least there is one valid move here, then it returns true. Okay, so now we have all the things that we need to actually validate and run the game. Let's build the UI. So here in the to implement, so we can pre-generate the UI. So let's create the buttons, and then let's call array from. And we already know that there will be only 9 elements in the game, so we pass the array like object, game size, in square, and then we remap this array. And we can just return div. Oh, actually, sorry about that. We actually have a state. So first we need to initialize the state. So let's do this. So we have a state, set state, and see we have the variable called init state. This is done for the testing. In some cases, we want to provide a state to verify that our game works. So if the state is provided, we will not generate this. So we call use state, and then validate if init state is provided. Otherwise, we call create game state. Now we have our state, and let's render things. So here we start writing the things because our state is 2D array. So let's map it. We call the state, then map, and we get our row and row index. And then we're going to map our row with a call and call index. And then we're going to return our div element with the data row. So we need to data attributes to later understand on which row we're clicked. And then data column equals to call index. and here it should be row index. And inside, we just place the number value. It should be just call. So if the call equals to null, then it's just empty, otherwise it's column, which means it's a number. Let's see why TypeScript is complaining. So here we have the state. Let's see. Let's make it type the state. So TypeScript is still complaining. I don't see the error still, but oh, it's because we don't have return statement. Okay. Now we should see our numbers being rendered. Let's try to look it up. So let's open the website and open the student.react and refresh the page. Now we have our divs rendered, but it doesn't look like the game right now. So let's add some styles. So we already have some styles imported, which is the styles module CSS. So let's assign the styles. So the first class name, styles, so let's call it grid, and then this will be our grid cell. And before we style this, let's also identify if our cell is an empty one. So we can assign appropriate styles to that. So we can call data empty, and then if call equals to null, the data empty will be true. Otherwise, it's false. One thing we can do right now as well. We also need to always track the index of the empty cell, because when we click on any number cell, we don't know where the empty cell is located. So we could basically iterate over the grid and every time find the empty cell. But there is a very good life hack that we can use. So we can initiate the reference, empty reference, and use the React reference, and then initialize it to null by default, and it will track the HTML element or null. And what this empty reference will do, it will track the element that has the null value. So here we can assign the reference, and if column equals to 0, then we assign the empty reference, otherwise it's just undefined. One sec, let's. So TypeScript is a bit complaining about the nulls and undefined. So let's make it happy. Let's make it happy. Okay, let's ignore the type error for now. This will be assigned, and we can fix it after. Good. Let's style this a little. So we open the styles module, then we have our grid, and we assign the display grid, and then we initiate the CSS grid. So our grid, so let's set up the grid template rows. Sorry, actually grid template columns. And each column will have the size. Let's set it maybe 150 pixels. And then we can also create the outer rows, which will be also 150 pixels. and then our cell by default will be black. So let's create the grid cell class. And by default, it's going to have the background of the black. And the font size, let's set it to maybe 2 rem. And let's also align the text inside through the flex. And let's assign the font weight to be bold to make it more visible. And the color should be white. Okay, so now we also need to style our empty cell. And for this, we can reference the data empty attribute. So if data empty equals to true, then we can change the background. So for instance, set it RGBA 0002. Good. So let's check how it looks like now. So if I refresh the page, yeah, you see now we have our game with an empty cell setup. And now we need to click handle the events. Right now, if we try to click, nothing really happens. Let's also set the cursor pointer and handle the clicks. So let's create the handle click, handle cell click, use, and then it will be the function, and it's going to be the React.mouse event handler. And our event has a target. And then we need to check if the target instance of HTML element. And then we need to verify that the row is set. And row target dataset row is assigned. And also we need to verify that target dataset column is assigned. And also we need to verify that our empty reference current dataset row is also assigned, and as well the column on the empty reference. So now instead of searching for the empty cell, we can always have this reference assigned through the React reference cell. And if it's the case, we're ready to initiate our validation. So we need to get the coordinates first. So the x1 and y1 will be equals to the empty reference. It's from where we are moving our cell. So this should be column. So let's assign it like that. And then use the plus to convert it to the number. And let's get x2 and y2. And also get the target dataset row and target dataset column. So now we have our two coordinates. And the idea here, we need to modify our original state. So for this, I can show you the life hack as well. So instead of copying every row within the 2D array, so the easiest thing to do is to invoke the structured clone. So the structured clone is kind of deep copy that completely copies the objects. It already has a good support in the browsers. So most likely you actually can use it in production almost. So here we create a clone of the state, and now we're going to exchange the cells. So we're going to take the clone x1, clone y1, and then clone x2, clone y2, and here we're going to do the destructural assignment. That's also the default JavaScript feature. X2, Y2. So what it just exchanges the cells. It just exchanges the spaces. So we just change the position of x1, y1 to the position of x2, y2. So, and now it's complaining a little. Let's see why. As in state, structure clone. Array of. Let's assign the concrete type. And I think okay, we forgot to wrap it into the array as well. Cool. So it's still complaining. Let's see why. Okay, for some reason it wraps everything into the. Okay. So let's see. X2, it's because we haven't converted this to the numbers. Sorry about that. Now it should work. So here we do the spot exchange for the destructural assignment, and before we do the assignment, we actually need to validate if we can do this assignment. So let's run if validate, and then we pass our x1, y1, as well as y1, x2, y2. If the move is valid, then we assign this. All right. And we also need to update the state with our clone value. Okay, so now the handle cell click should work. So let's quickly assign this to the top grid. So here we assign the on click, and then we pass the handle cell click.
Do you want to close the Project Explorer?
Oh yeah. And let's verify that it actually works. So let's go back to the browser, refresh the page, and now see. So let me try to exchange it with the cell with the 5. So now it works. And the only thing that doesn't work right now, so if I try to click on the 4, it shouldn't allow me to go there. And if 6, it should allow me to go as well. And if I move the cell here, it should display that we have the win condition. So we haven't called the win validation yet. So let's do this. Here at the top, let's also have another container. Let's wrap it actually into the div and write a simple text like this. So we check if is win. Then we show the text you win. Refresh and move the cell to this point, and you have you win. And that's the problem. Any questions before we move on?
Not seeing any.
Okay. So let's recap what we've done. So first we sorted our array, then we chunkified it into the 2D array, then we created our game state, then we created a validation function to validate if the move is allowed. And then we checked. So here on the slides, as an example, how we would look for the empty cell. So in this case, you would need to iterate over the whole grid to find an empty cell. But we found the life hack using the React reference to track it. So instead of doing the ON check on the array. And here we check the win condition. And then we do the rendering of the game. And the final thing is we are calling the handle cell click and assign it to the top level element and handle it through the event delegation. Okay, so the next is a TypeScript challenge. So we have a challenge called replace. So what this thing does, it takes the source string. For instance, here is the types of fun is a string, and we want to replace the word fun into the awesome. So the resulting string should be types are awesome, and we're gonna learn how to do this in the type system in TypeScript. So let's get back to our IDE. Open the challenge. Folder 43, challenge 21, and let's implement this. So let's create our string, our type called replace, and the first argument will be the source string, which should extend the string. Then we have the what we're searching, so the target. It should also extend string. And then we also have the replace with which string we want to replace the target. Okay, so let me split this into the multiple lines and close the project viewer. How do we solve it? Again, we're going to use the pattern matching through the extents. So what we can do, we can check if string extends the following. So if the string extends so let's call infer first. And then somewhere we have our target string. And at the end, we can have some tail. So what this thing does, it basically asks TypeScript to match the string, and it asks, okay, if the string matches the following pattern, so the target should be somewhere between the string, and we can match the head, so the head can be also empty string. So even if we don't have any symbols behind, we will still be able to match the string. And if we match the following pattern, then we can reconstruct the string by taking the head of the string, then taking the target, using the replace instead of the target, and applying the tail. And if we don't match, we just return the string. So here now almost all test cases pass. So the only test case that doesn't pass if the replacement, if the search value is empty. So for this, we can verify that if the search value is empty, then we just return a string. Let's check this. If target extends empty string, then we return as, otherwise we do this big check. Okay, that's the replace challenge. I suspect there will be questions.
So just single replace or do we do recursive?
It's a single replace.
Okay.
Yep.
Is there a reason? Let me rephrase this actually. How might you use this in production, or should you use this kind of thing in production?
Not all challenges are usable in production, but for instance, some use cases is when you dynamically generate the string values. So for instance, in the abstract component in this case, we were converting the on-click mouse down events into something like this. So on-click and mouse down. So, and in order to properly type the expected methods on the class, we can use the string constructor. So we can take the mouse down as a type value, and then type our class to automatically have these types available on the class itself. So through the dynamic inference. That's the kind of advanced TypeScript technique that we can use in the dynamic classes.
And is there a way to do this without the ternary operator, since nesting ternaries are hard to read?
No. So that's actually how the matching works. So we always need to use extends.
All right, I think that's it. Good questions.
We have one more. Deep read-only. So now we want to take an object and convert it to the deep read-only object. So this is the follow-up problem that we had in the beginning, where we had just a single read-only object. So here we're going to build the deep read-only generic, which accepts the type T, which should extend any object. So let's jump to our IDE. And open folder 44 deep read-only challenge. And here we have our target type of the object, and we need to make sure that we remap it into the deep read-only object. So let's go. So let's create a type called type my deep read-only. And as you can see, it should accept the object as a target. No, actually, because we can also accept the primitive values in the recursive calls, for now we can just limit it to T. Okay, so how can we do this? So first of all, we need to verify that the value is an object. So to do this, we can check if T has any keys. So if T extend key of T extends never, this means that it's the primitive value. So we'll just return T. Otherwise, we're gonna remap the properties for we're gonna iterate on the keys. So key of property of in key of T. So here we'll loop over the properties of the T and then take the value and assign the value. One thing to note here is we're not making it read-only yet. So let's add the read-only field. So now we have the shallow read-only working. So in the next case, because we need to verify that the value is also, if the value is object, then we call it recursively. So we call the my deep read-only and do the recursive call. And let's see if the test, oh, it's actually just called deep read-only. And the test passes. That's how we do the deep read-only. Any questions on this one? Okay, so let's move on to the next problem. So I actually scheduled a technical break, but we can continue if we...
Yeah, I think Yeah, like we don't need one for another, 20 minutes, and then I'll probably align with our lunch break. So yeah, let's just go for another, 20,
Sounds
30
good.
minutes, and then we'll take a break.
Okay, so the next problem is quite complex one. This is called portfolio visualizer. So essentially, we need to visualize the tree of the portfolio, of the financial portfolio, which could have multiple levels of the nesting, and each level can be expanded. And also, we'll need to enable the editing. So I'll show you how it works. So here's our input data. So essentially, it will be the tree. So the total portfolio node will have some value, which is basically the total sum of all children within the portfolio. And here we have the deeply nested structure. So imagine that you have the $10,000 portfolio, 8,000 are allocated to stocks, and then from this 8,000, you have 5,000 allocated to Apple and 3,000 to Tesla. So that's your portfolio. And the first part of this problem will be just to render this data. And this will look like something like this. So we have each node, and when we go down, deep down into the tree, you have another node with the value, and it shows you a percentage of total allocation of your portfolio. And here you see we have the inputs. So as a follow-up, after we render the UI, we're going to also implement some logic. But first, I think it makes sense just to implement this UI on the input data, and let's not dive into the input logic for now. So if we're clear, let's go to the property model of this component. So the single portfolio node will have the ID, which is the ID of the node. It also will act as a ticker for certain stocks, and then we have the name, which is the full name of that we need to display in the header. Then the numeric value, which represents how much is allocated to this specific ticker. And then we have the children nodes, which is the deeply nested structure of other nodes. And our overall application takes the data as the single portfolio node, and then we render this data. So let's jump into the code now and start implementing this. So open the portfolio visualizer. It's the problem 53 portfolio visualizer UX, where we're going to focus on the UX. And we're going to use the React again for this problem. So here's our expected data. And what we need to do, we just need to take this data and render the node. So before we start rendering this, let's create a class. Let's create a component called portfolio node, which will accept a single node and render it. So now I'm creating a function called portfolio node. And it accepts the single portfolio item as a node. The portfolio node. And the node itself can have ID, name, value, and the children. Okay, so the node will be using the detail stack that we already know. So this will allow us to easily build the deeply nested tree hierarchy using the native HTML element. So we use the details. Then we're going to use our summary. And inside the summary, we'll have two fields. The first one is the name of the node. So we can use the strong tag to make it bold. And then we're going to place our input. Assign the node ID to this input, so later in the future we will be able to track the to handle the events for the change events for each input. And then for now, we assign the default value as value. So that's the for now the current logic. So the input will stay kind of read-only, so it will not track any change event on that. Okay, so the next we'll have the output field, which will track the percentage of the allocation. Let's calculate the percentage as well. So for this, we need to sum. We need to take the value and then we need to take the total of the portfolio, but we don't have this property yet. So let's extend our property model here with the total number. And this will be the total portfolio value. So now we can divide the value on a total and use the total as well. And let's also use the math round and then round the value. And use the fixed precision, which will be 2. Oh, maybe we actually cannot skip rounding the number and just use the fixed precision here, like this. Okay, so now we have the percentage. We place the percentage here. And now we can render our child nodes. So inside here, we can create the unordered list tag. And then inside, we can map the children into the portfolio node. And also and render the portfolio node recursively. So we can take now this component and return portfolio node. Data, and the total value will be the data.value. If we open this now and see what's the result, let's go back. Let's open the problem called portfolio UX. So let's hide this. Student React, refresh the page, and see it now. You kind of have the list of all the stocks. It doesn't look good, so let's apply some basic styles to make it look a bit nicer. Here, each list will have the some padding. So let's refresh. Let's also maybe add some the margin between. So we can also add the styles, padding vertical, and let's add the 16 pixels as well. Refresh. Okay, so we can also add the summary padding. Let's actually do this thing. Instead of applying this to the list, we can apply it to the summary. Styles CX styles padding 16. Okay, so let's refresh the page. Yeah, that looks kind of it. So let's maybe reduce the padding a little bit. Okay, so now we have our tree, and I think by default we could add the by default we could have it opened instead of opening it every time. So for this, on the details tag there is an open property, and we just set it to true. And if we refresh, you see now we have this a nice open tree of the elements. Now I want to resolve this bit, so it looks not super nice. So ideally, it would be great to kind of align this using the flexbox. So let's see if we can apply some styles. So for instance, if I apply display.flex and then justify content space between. Okay, so in order to properly space it, we probably need to merge the input value and the percentage together. So the input value and percentage will be on the right, and the portfolio node name will be on the left. Let's do this. So we've wrapped this block like this, and then assign styles flex between. And let's refresh. Now we see kind of the structure that we want. So it's not 100% aligned, but I think for interview purposes, we can just keep this alignment and continue as it is. Okay, this was the main part of the UX. So now we need to implement the follow-up tasks. So let's move back to the slides, and there will be follow-up requirements. Okay, so what are our follow-up requirements? So first of all, we need to enable editing the nodes. So this means that we can edit every leaf, but there will be rules. So the first rule is if we reduce any node to in the value, and we haven't reduced the parent, so this means that we now have available cache within our parent node. So this will be calculated as the unallocated cache. So we will need to dynamically add the unallocated cache node here. So also, if we want to reduce the parent value, so now we can reduce the parent value by the cache node. So for instance, we set the cache to 0. So our parent node should automatically reflect the change and reducing value. And we should stop displaying this. And if our the most parent node has the unallocated cache, and we decided to reduce our total portfolio, our total becomes less, and the unallocated cache disappears. So also we have the budget constraints requirements. So first of all, the parent value cannot be reduced below the sum of the children. So for instance, you have your stocks value and you try to reduce it by $300. You cannot, because you have a children, the value of the 600. So this assignment is invalid. This assignment and restore the state. Another rule is the child cannot be increased beyond unallocated cache. So, for instance, we have the unallocated cache of the $100, and then we try to increase our Tesla stock by $200 because we don't have this available unallocated cache. We cannot do this. So our rule, so we don't want to change our node, and we need to drop this change. That's the budget constraints that we have. So in order to solve it efficiently, what we need to apply a normalization technique. This means that the current tree structure is not very convenient if you want to process it. Because if I click on the Tesla, I need to find the parent. And because we are handling using the event delegation, and we only have the parent ID, so we need to initiate the search for the root node, and we kind of want to optimize the search by basically having the flat map. So instead, we'll have the map where each node has the ID, and this ID will be linked to the node. So instead of working with a tree, we'll kind of have the normalized state with all the values inside. And in order to do this, we'll need to pre-process the data that we have in a tree. So this will be our first step, pre-processing the data. Let's get back to IDE. And for this, open the problem 54 called logic. And let's open React. So it's basically where we stopped in the previous problem, 53. And here, our portfolio node has the children, and our portfolio state node has a new type. We're just overriding this. And I think to make it more simple, we don't really need this this type, I think. But let's see. So instead of keeping the children array like this, we probably just can keep the string array instead. Because if we want to move into the flattened structure, we don't really need to track the full children. And later, if we want to normalize the state, it will be much easier to clone the state if we don't have this nested structure inside the state. So this will be our new portfolio node that we need to transform into. Now let's create a function that will process the initial input into this new structure. So here I use the omit function, which basically removes the children value from the portfolio node, and here we override the children to be the string array and add the parent ID to establish the link between the nodes. Okay, so now let's write the function called process, and as an input it takes the data t portfolio node. And what this function does, it will go through all children. So this means that what we're going to do is we're going to loop through all children. And then we need to have the utility function that will do the recursive call. Let's create a function called walk. And it will accept a single node, t portfolio node. And let's create a store where we place all our nodes. New map, string, and t portfolio node state. So inside the walk function, we need to construct a new node that we will place into the normalized state. So let's construct it. And our nodes have the few fields called the parent. And here let's add the parent ID as a string or null, so we can assign the parent. So we pass the parent, and also we need to remap the children. So we take the node children and remap it to the ID. So instead of keeping it as a full object, because now we're moving towards normalized state, we only need to know the ID to get the child node from the state. Also, we reassign the other values. The other values are ID, name, and so it's ID, node ID, value, node value, name, node name. This is the new node. And now we're storing this node in our store. So we're setting the node by the ID and then the new node. Okay. And now we need to repeat the recursive call to do the same with the children. So we do this for child of node children. So if the children is empty, we just use the empty array. And then we call the recursive call child and set the parent ID here. Okay, so now we have the walk method that creates the normalized map. And here we just initiate the walk. Data, no. And then we return the store. Okay, so this should process our data, and we can now call it here in the use state. So let's create a state. Set state, use state, and then call the process data. We can do it even asynchronously, not to block the UI thread, and do it like this, process. And now we should have our data normalized. And in order to render the normalized data, we also need to change the way we pass the parameters inside. Let's do it as well. So now our portfolio node will accept the store. So ideally, we kind of want to use the use context in this case, or if you, in the Redux world, you use the Redux state, so you will kind of have the global state, and each node will be able to select a specific value, and it will be more performant, because when you update the whole context, all the children of the context will be re-rendered, unlike the Redux. So here we just have the global state, which will act as a main context, and we'll drill down the global state without using the context. But you can use the context as well, but I just think that just drilling down this property will be easier to implement. Okay. Since we get the normalized data, we need to find our root node now. So let's use this. So we're going to access our state, object, state, values. And then we're going to filter the nodes and find the node without the parent. And this will be our root node. And here, we're going to pass the root node data. And then we're going to pass the store. State. And let's update the portfolio node to handle this situation as well. So now we're accepting the overall store. So actually, instead of the accepting the single value, okay, let's keep it like this for now. Let's add the store to the value. So now it's T portfolio state node, and total number and store, which is the map of string of T portfolio state. And now we should have this available in our properties. So each node now will have access to the to its store. Okay.
And do you want to close the Project Explorer again?
Yeah.
Cool, thanks.
Let's check that it's actually renders. So there are a few things that we need to fix. So first of all, now we map for the children. The children is just a string array. So we want to map it and instead access the store. So here we use the store, get the ID. And it will be just children. and then we pass the store as well. Okay, let's see if we have everything in place. So here we're missing the total, so let's pass the total as well, and it will be a root value. So we can replace it with just find. Okay, let's go to the browser now. So basically nothing should change. So if we update the page, we should see, okay, we need to actually move to the another portfolio visualizer logic. Here, if you open the student vanilla, React, here is our portfolio, and it still renders the data. So now we need to implement the budgeting node, the budgeting rules that we have. So in order to do this, we're going to register the event handler on the top level div here. So instead of again registering it on every child node, we're going to catch it at the top level. So let's create an event handler called onNodeUpdate. So this will be React keyboard event handler. So we will need to click enter to make sure that we to submit the value into the input. Keyboard event handler, and then our event handler will have the target and the key. And now we need to validate that the key that we're pressing is the enter. So if key equals to enter, sorry, not equals to the enter, then we just return. The other case, if target instance of HTML elements, so if target is not instance of HTML element, then we can also return. And now the last check is if our target element has the ID assigned. So here we have the data node ID assigned to each input. So this means that we need to fetch the node ID. So if target dataset node ID, so if it's not assigned, we also return. So, and I'm splitting this into the multiple statements just for you to see, to basically make it more readable. Okay, let's get our node ID now. This will be our state. And since we have now normalized state, we can basically get our node ID, we can get our state, our node, by just using a single ID, like this. Okay. And if node is null for some reason, we can also return again, but this should not be the case. It's for basically making TypeScript happy. Okay, now we have the node value, and now we need to implement the budgeting constraints. So our first budgeting constraint is that the new value should not exceed the children values. So first, let's calculate the sum of the children's. Let's do this. So we calculate children sum, and this will be node children reduce, and then our sum will act as an accumulator, and then we're gonna add the value of the each children node. So we access our state, get ID, and if ID is not found, it will be just 0. And then we pass the 0 value as the initial value of accumulator. Let's see if, okay, probably we need to wrap this into the brackets. Dot value. This let's fulfill the first budgeting rule. So if, and we also need to get a new value. So let's also do this, but new value, and the new value is assigned to our target element, which is the HTML input. Target dot value. So if our new value is a valid number, and we need to check this by using the number is none. So if it's not a number, that means that we need to cancel the transaction. So for that, and just return. And because the value is already set on the input, we need to override it back. So we take the target dot value, and then it will be just equal the node value which is currently assigned to the node. Okay, so now we calculate the children's sum, and the first budgeting rule: if the node value less than children's sum, then we're going to have the same issue that we need to return. This means that the transaction is invalid. We need to reset the value and also return. So this is the first budgeting rule. The second budgeting rule is that the new value should not exceed the value of the parent minus the sibling sum. So what this means? So in some cases we have unallocated cache, and we have available and we cannot exceed the value cannot exceed unallocated cache. In this case, that's how we calculate the second budgeting rule. And I know this rule is a bit confusing, but try to read it through again and read through the code, and you will understand why it's here. Okay, so the last one. Let's calculate the sibling sum. We take our node, in this case children's sum, minus the node value. So this gives us kind of unallocated cache. Unallocated cache. And our check will be if unallocated cache is less than new value, then we're going to repeat the process and reset the value and cancel the transaction. Okay. And finally, so since now we validated everything and all the rules passes, this means that we need to update the node value. So what we do, we update the node value. Basically by setting the new node, creating the new node, and then overriding the value to be new value. Okay, now we need to create a shallow clone of the map. So here we're creating the clone on the map of basically passing the current state to the map constructor, and then we're resetting single node with a new node. and setting the state. Set state, clone. And that's a lot. That's a big function that we're handling. And I know that's, yeah, it will take a while for you to understand this. Let's make TypeScript happy here. So now we have our own node update. Let's register this one here. On key down, and then we handle on node update. And let's verify that we have everything in place. So one thing that we can potentially optimize, instead of passing the full node structure here, we can just pass a single ID. So instead of doing this, what we can do, let's remove the whole thing. Total, so children name value will be removed. We keep this ID, total, and store, and we're just gonna have the following structure: ID string, because we can get our node from the map. Now we can look up for our node for the store. This will be get ID, and then we get our values that we were just structuring before. Okay, that's the first optimization. The second one, when we change the value, we need to somehow also update the input. Because right now, the way the input works, we type something and then send for the enter key, we submit the value. But if we directly assign the value like that, the component will become controlled, and we'll need a change handler, which will change the value of this input. So we don't want that. And for this, we need to set up a use effect that will take the value of the node as a dependency and will manually update the node. And in order to do this, first we need to set up the reference to the input in order to access it. Let's create input reference. Let's import this. Is it imported? Yep. Okay. Now we assign the reference here. Input reference. And now let's create a use effect. Use effect, which will have the dependency on the current value. And if the value changes, then we'll manually update the input. Input ref, current, like this. Okay. Last step, unallocated cache. So we still have unallocated cache to display in the structure. So to compute this, we're going to take the value of the parent node and in order to access the parent node, we oh, one sec. Actually, it's we just need to compute the sum of the children. So we compute value minus children map. So reduce and then we're using the accumulator and add the value of each children. So access the store, get child, and the same logic as we've done it before. Value 0. And let's initialize the accumulator as 0. Okay, let's see what is wrong in the syntax. Here we get the value. Does anyone see the syntax error? Okay, let's expand the function to make it easier.
Yeah, you,
And you're missing a
print
I think it's
parenthesis.
something with the initial value is.
this parentheses should come before the initial value, not after.
1 second. Here we pass initial value, and
I think you need return.
yeah,
Return.
return sum plus accumulator. And we forgot what did we forgot? Okay, maybe this is because this one. Yeah. Value minus children. So now we have the accumulated cache calculated, and let's output this somewhere below. For instance, here we have the older children outputted, so let's create a section, another section. If accumulated unallocated cache more than 0, then we just output unallocated cache. Otherwise, it's just 0. Okay, so let's see why the target values value doesn't exist on HTML element. That's true. So let's change the conditioning and check if it's HTML input element. And now all the TypeScript warnings are gone. Okay, let's test things. And it looks like the unallocated cache is incorrectly calculating, so let's verify what is wrong. So we take the unallocated cache is calculated as the value. Okay, let's calculate the children sum first. Children sum. Oh, I know the reason. The unallocated cache can only be calculated if we have children. So let's see, const unallocated children length more than 0. Then we use the value minus children sum, otherwise it's just 0. Okay, so let's refresh the page. Now let's test things. So first, let's increase the size of the portfolio. So make it, for instance, 400,000. And click enter. So when we click enter, nothing happens. And this means that our click event handles something, but it doesn't work. So let's now debug why it doesn't work. Let's open our click handler and put the debugger, and let's go line by line. So I'll try to increase the size of my debugger. I hope you'll be able to see something. Okay, so let's type hit enter. And do I have my debugger disabled? Okay, we need to refresh first. Okay, and let's change the value now to 4. Okay. Let's go line by line. So if the key is not enter, it should return. So the key is, oh, okay. So the key actually is 4. And I know what is the reason. So there is also another property called key. Sorry about that, because I changed the value to 4. That's why we ignore for now. And let's see. If key not equals to enter, maybe because we are trying to filter the enter key, then it fails to overall assign the value. Let's verify this. If key is not enter, then the target so the reason why we're failing, we're returning from the event, and the event just stops. So we need to wrap the whole thing. If key equals to enter, then we continue. So let's copy this code. Oh, that's terrible. Put it here. We have a nice neon cat. And okay, let's refresh the page and see if it changed anything. Disable the handling. Enter. Still doesn't work. And let's debug again. Hit the key. Click enter. Alright, so if the key is not backspace, I feel like I'm making some weird mistake, and it's hard to see it. But let's try to. Probably because this conditioning means maybe my conditioning is wrong. So let's verify that.
Since lunch is here, we could, if you wanted to debug, we could do our lunch break, and then you could kind of debug, and we could eat, and then we could just do the
Yeah, sounds good.
right after we come back. So
And it is sushi, so it's quick to eat. So we
Yeah.
could do like app over lunch.
yeah, we'll do
Just take
30-minute
it
lunch break.
If you're okay with that.
Yeah,
Yep.
sounds good.
And for those online, if you're playing along, you can check out the repo for the solution too.
Welcome back. We'll continue debugging our problem. And last time we noticed that when we enter the value, it basically returns the value back. And basically the reason for this is the issue with this condition. So here, see, we're using the old value on the node and comparing it with the children's sum. So that's why it doesn't pass. We need to extract a new value from the input itself. So for this, we'll need to fix the code. And let's get back to our code. And here, let's remove the debugger for now. And where we extract the new value here, we need to make sure that we are comparing the new value, not the children's sum. And if it doesn't pass, then reset the value. There is also one more issue. Here, we're trying to calculate unallocated cache incorrectly. So essentially, to get the unallocated cache, we need to access the parent node first, because when we click on the node, the unallocated cache is kind of a sibling to the current node. So we need to get the parent first, and then calculate the available unallocated cache. So first of all, let's fix this error as well. One thing that we need to have the parent ID. And because we already have the node, we know the parent ID as well. So we can access it by creating a variable called parent ID. And then we access that node parent ID. And if the parent ID is available, then we need to run the check. So let's so for now, we can remove this statement. Let's clean this up and rewrite the code a little. So first, we accessed our parent. We access the state. So get parent. Now we need to calculate the sum of the parent children except the current node that we are trying to change. So this will give us the correct value of the spare cache that can be assigned. So next thing, we calculate max allowed cache, and then we take the parent and then access the children, and then we use reduce, pass the accumulator, pass the next value. So now we need to return accumulator plus store get value, and if the value is null, let's just assign it to null. So, and also pass the initial value, which is 0. That's how we get the max allowed cache, and we need to subtract the current node value. So minus node value. Okay. So let's see where the syntax is complaining. This is here. So let's assume the empty array and then reduce. So this is the maximum value that's right now available to us. And we need to check if the new value doesn't exceed it. So if the new value exceeds the max allowed cache, then we just return and reset the node value as well. Okay, and if it's not the case, then we continue, and here we're resetting the node to a new value. One thing to note here is the store is red. Let's see why it's complaining. Okay, it's actually state. All right. So now we verified that the new value can be assigned, and at the end we'll need to reassign the new value to the node and setting the state. And now we should be able to see the results. Let's get back to the website, refresh the page. Let's remove the debugger for now and refresh the page. Okay, let's try to change the root node on the portfolio side and hit enter. And as you can see, now we have the allocated cache 100,000. Let's try now to add this cache to the, for instance, to the stocks. So let's change the value to 5 here and then submit. And now, as you can see, the unallocated cache is updated here, as well as it's propagated to the stocks as well. So now we can also verify that, for instance, we cannot increase the Apple value beyond the unallocated cache. So here we only have 50,000. So if we try to increase it to the maximum value, if I click enter, it should reset the node. So see, it's now resetting the node. And also, if I try to increase now within the allocated cache limit, for instance, to 80,000, then if I click enter, let's see, and it didn't work. So let's see why it didn't work. So if we hit enter here, it should work. So let's continue debugging then. Let's place the debugger here. Refresh the page. So let's disable all the debug points for now. Replicate the previous situation. So here unallocated cache, then increase the stock value to 150, and then we try to increase the Apple. So we again enabling debugger, increasing to 80,000, and then click enter. And let's debug line by line. So here the parent ID is stocks, so it's correctly getting the stocks value. Now we're calculating the maximum allowed cache, and let's see what's the value it sets. So it sets the value to be 70,000, and let's verify if it's correct one. So it actually should be. And our next new value is 80,000. And let's verify if it's actually correct value. So we had the 30,000 here, and when we try to increase to 80,000, it should be actually 80,000. So we're probably missing something here. So let's see how the max allowed cache is calculated. Let's go back to the code. So we take our children, and then we're fetching all the values of the children, and then we're removing the value of the current node value. So the current children value should be equal to let's see, so it was before 30,000. So, and if we, yes, so this should equal 70,000 of available of the cache.
Right.
And there is error in the formula, I think.
So max allowed cache is just the sum of the values of the children. So the allowed value should be the value of the parent minus the other children.
Yes, that's actually correct. So let's create a constant and recalculate the children's minus not value. and then fix the conditions. So the max allowed, this is actually a correct statement. So we need to subtract the parent value from the parent value, the sibling sum. So we use the parent node, the value, minus sibling sum. This will be our max allowed cache. And now let's see if it works. So we refresh. Let's replicate again the situation. 400. Then we increase to 150. And then we increase to 8. And let's enable debug. Click Enter. And see if the value is calculated correctly. So the sibling sum equals to 70,000. That's correct. And then we subtract this from the parent value. And max allowed cache is 80,000, which is correct. And this statement doesn't pass, so this should work. Yes. And the value is updated. So let's recap the conditions that we need to implement. So first of all, first we needed to implement the unallocated cache. And let me do the enter the full screen instead. When we have the unallocated cache, it should be displayed as a separate node. So let's again test this test case. Go back to the to our application, increase the, let's refresh the page again. So we're increasing the value, and then now the unallocated cache appears. So if we try to reduce the value to 35, and we click Enter, so the allocated cache is updating. So this case we handled. The next one is budget constraints. So the first rule is parent cannot exceed, the parent cannot be reduced below the sum of the children values. So let's try to verify this. So we have the stocks of the value 100,000, and if we try to reduce it to 5,000, so we cannot do this, so the node is reset. So this constraint is implemented correctly. And then the next one is the child cannot be increased beyond unallocated cache. So if we go back and we try to increase the stocks to 160, and our allocated cache is only 50. So if we try to do this, it should be cancelled as well. Yes. And if we try to do 50, it should be assigned. Yes. So this means that our cases work and all the requirements are fulfilled. All right, so let's recap what we've done. So first of all, we normalized all the input data into the normalized store where we can access any node using the ID. Then we implemented the portfolio node. So we're using the detail stack with the output to create a tree. And then we use the event delegation with the handle key down to handle all events throughout the application. So we're creating only one single point of event interaction that we're handling. And yeah, that's the we finalized our second hard problem in the components section. And I know it was quite hard one. So especially if you get this on interview, you have so many conditions to fulfill, and that's kind of the problem you may get in the top companies because they want you to be sharp. And that's why we're practicing here on the problems that are very complex. And even I, as an instructor on the workshop, sometimes need to debug the problem as well. Yep.
In a real interview, what would be given to us? Like scaffolded code with comments, or view only, like no code to, like a reference to click through? And would any sort of tests be included?
It depends on the company. Some company provides some scaffolding with the basic UI that you already can click and you only need to implement the logic. Some companies prefer for you to do everything from scratch. So it really depends. So you can be in both situations, but if you're required to do everything from scratch, you can assume that you will have a bit more time to code it. Obviously, you will not have a reference. You most likely will have some very basic mock-up UI that you will need to implement. If we don't have more questions, let's move on. Okay, we're entering the boss areas. So the next problem will be the ChatGPT client. And this one is going to be quite interesting. So first of all, we'll need to create a basic version of the ChatGPT client where we can just write some text and get the dynamic response from the server. And one thing that we need to implement as a part of ChatGPT client is the Markdown engine. So the server responds with a Markdown, and this Markdown should support tables, headings, an ordered list, links, and some basic text formatting. So we need to parse this binary text, and then also parse the Markdown and convert this into the HTML. That's why this problem is kind of have the extreme level of complexity. So one thing that we are provided with is the endpoint where we get the binary data of the Markdown, and also we are provided with the regular expression to parse this Markdown, so we don't need to come up with our own regular expressions. And in order to solve this problem, we need to decompose it because right now it's a quite complex one. So first, I think we'll need to focus on the server part. So how we handle the text. So the chat UI will request the data from the server and the server will respond it with the service send events. So essentially, it will act as a subscription. We'll get the binary chunks of the text through the events, and then we need to get these chunks for the UI and send them to the Markdown engine. So first, we'll start with the Markdown engine. And Markdown engine itself is a complex problem on its own. So in order to implement this, first, we'll need to build a rule system, how we parse the text. So in this case, imagine that you have a rule, and then this rule knows how to parse the heading. And each rule can contain multiple patterns, so it can be the pattern how to parse H1, how to parse H2, H3, and H4. So you can have multiple patterns. And as an input to this rule, you get the you get the text. So and basically, this rule accepts the text and goes through each pattern and modifies this text and outputs a new modified version of this text. Then you pass the text to another rule, for instance, the list, and the list rule will have its own patterns, and then it will process the text, replace the patterns that matches the text, and then it will output the resulted text. So we'll need to build a rule system and the pattern system that we can use. And then the text that we're processed will send to the chat UI, and then we can render it as a Markdown, as HTML. Sorry. So the whole engine will convert Markdown to the HTML. That's the idea. And this is the part of the ChatGPT exercise. First, we're going to build this engine. And here is the simple example. For instance, in order to parse the heading, that's how it could look like. So here, the heading has the two starting symbols, and if it has two symbols, then this means that it's heading 2. If it has just one symbol, then it means that it's heading 1. So, and we're going to apply this pattern system for each rule. So in order to convert this to the OOP structure, let's define the class names. So we're going to call the rule rich text rule, and we're going to call the pattern as a rich text pattern. And rich text rule can have multiple rich text patterns. That's the idea. And then the main interface that they're going to utilize, we have this single method called apply. So the apply will take the source string and then outputs another string. That's how it's going to work. And as you can see, it's kind of going to be a pipeline. So first, the string goes to the heading rule, then it goes through the pipeline of the patterns, returns back, and then we execute the next rule, which is rule list. And this is how we circle the string around until we get the final result. And before we jump in, I just wanted to explain the regular expression part. We're not going to... Thank you. We're not going to write these regular expressions, but I think it makes sense for you to explain how it works. Imagine that you have the URL, Markdown URL, which has the text inside and the URL itself. How do we match this? So in our exercise, we already provided with this regular expression, and I know it sounds like it looks like it's impossible to understand, but here it's essentially we're parsing 3 groups. So the group 2 is a text, which is here. So here we're parsing we're saying that okay, this group should start with this the left bracket, the rectangular bracket, and finish with another bracket. And then we use the circular brackets to create a group, so which we can reference later. So similar thing happens here. So we are wrapping the group into the circular brackets, and everything inside we're trying to match with the regular expression group. And the first group is just basically a utility. So for instance, if link has some beginning value, some space or the symbol, then we're trying to match the symbol as well, so we can preserve the whole content. That's how the regular expression works. And yeah, you don't need to kind of deep dive onto each regular expression, but I think understanding the basics of the regular expression actually helps. And this is how it's going to work. So the replace method has 2 parameters. The first one is the regular expression that it accepts, and then it has the replacer string. So the replacer string allows us to reference the group that we're matching. So here we match the first group, which is all the symbols before the link, and then we have the second group, which is text, and we place this text into the tag. So we're converting our Markdown into the text. We placed the link text inside the A tag, and then we extract the third group here and place it into the href attribute. That's how we convert the Markdown link. So the whole Markdown link will be replaced with this, and groups will be automatically inserted by the JavaScript replace method. And we'll get our shiny link as a result. Okay, so let's go to the code now and implement the OOP structure of the rules. Open the Markdown. This is called Markdown Parser, and we'll start with the parser first. We already have some default types. So for instance, we have the replacer function type, which takes the content, and then it accepts the either replace function or the replace string. Then we have the parent tuple, which is defined as regular expression and replacer. Here we already provided with the regular expression to parse the link, the headings, and so on. So let's try and start implementing the replacer functions. So here, all the groups are already described. So the first group takes the characters before the link. So the second one takes the link text. The third one takes the URL inside the circular brackets. So this means that to implement let's hide this so you can see more text. So this to implement can be replaced with the following. So we'll have the link. Now we know that the third group is the URL, which should be applied to the link. So we write href, and then we place the this $sign with the free, which tells the replacer function that we need to insert the third group inside this. So this is already provided by default in the replace method, so you don't need to implement this. Then we need to insert the second group inside the A tag, and here we place the first group because it's something that we have before the link. So, and we're done. So now, if I try to execute this, so let's uncomment. Here we have the link, and we try to execute this this function. It should output the link. So let's run it. And as you can see, we successfully replaced the Markdown with link. And we need to repeat this process for the remaining of the files. So here in a heading, we know that here if we have six symbols, then it's the H6. But in this exercise, we're replacing H6 with just the paragraph. That's how the tests and example are set up. So we can replace it with anything that we want. Okay, and now we provide the first group here, and the first group will be inserted here. And if I try to run the replacer function on this title, it should convert to the paragraph with the text. Let's see if it works. Run, and see the paragraph is outputted. Cool. And now we just need to repeat this process with the remaining headers. So let's do this. We'll run H5. And we can copy this as well. Replace. Here it should be H4. H3. So we're going from more specific to less specific. So the first will be 6 signs, then 5 signs, and so on. H2 and H1. Okay, now we have the way how to parse all the headings. So the remaining bit is the paragraph is already provided to us. And now let's implement the bold, italic, and the strike-through text. So this is relatively simple. So if we just wrap in the bold text into the and using the same pattern by matching the group. So we have one group, and this group appears between the B tag. And the same structure here. And the strike through, we just use the S tag. Okay, let's verify that this works. So let's run it again. Okay, we have the syntax error. Should be fixed now. Let's run again. So see, the strike through is applied. So this means that we are correctly calculating this. Okay, now the hardest part. So we still have the unordered list and ordered list. And the way the unordered list and ordered list work is we have this complex extra expression that we run. And then we, instead of providing the replacer string, we can provide the full match string. So let's remove the code here. I can explain how it works. So the full match, it's basically what we match within the Markdown. So if I try to console log this, and run, you see that we match the list of items. It's A and B. So now we can transform this A and B into the Li items. And for that, we need to take the full match. So we take the items, we take the full match, and then we split the match by the next line symbol. If we console log the items now and run it, now we have the items A and B, so we can continue transforming them. So let's now remap them. So here we're gonna map them, and we're gonna use the I item and substring the item. So we're gonna remove the minus symbol and the space, and wrap it inside the Li item. And if we try to console log this, you will see that now we have the Li items applied, and we basically parsed our Li items. Okay, and what do we do next? Now we have the Li items. We want to join to join these items into the single string, join, and return our unordered list using the alt text and items. And if we try to output this, what we get? So we try run, and you see now we have our unordered list parsed. And the same logic is applied for ordered list. So we do the full match, we split by the new line symbol, and we do and we're wrapping everything into the unordered list here. So one thing to be aware, when we create a new list, we need to make sure that it always starts from the new line. That's it. So the next one is the table. So the table is provided as a part of exercise. I don't want you to too much focus on the how to parse the table, but essentially what it does, it takes it parses multiple groups. So the first, it parses the header, then it parses the separator row. We just discard the separator, and then it parses each row. Then we transform the headers into the HTML headers, and then transform the XML rows into the cells. So don't if you think that it's too complex, don't worry too much, because yeah, that's how the Markdown engine works. So it takes the Markdown engine itself is just a set of complex patterns which you transform into the HTML. But now you have the structure, how everything works. Okay, so now we can actually build our classes, and the first class we need is the class that represents the single pattern. So let's create this one. We'll call it rich text pattern. And inside, it accepts expression, which is the regular expression. And when we can automatically assign public, so it can be assigned to the constructor, to the instance. And then it also accepts the replacer function, public replacer. Okay, so now we need to implement the apply method. So the apply method takes the source string and modifies this. So we take our apply, we accept the string as a source, and then we just apply a single pattern for replace, this regular expression, this replacer. And right now it's complaining because the typing doesn't match, and we can just for now call it as any. Okay, so now we need to build a rule that will contain all the patterns. So let's create another class called trich text rule. And then we have the constructor, which will accept the array of the patterns and the name. For instance, if we have the headings, we can merge them into a single group and say these patterns will have will parse the heading. Okay, so now we implement the apply, and in order to implement the apply, we're gonna run so we create a variable result, assign it to text. Now we're gonna loop through the patterns of these patterns, and then we're gonna process the result string by running result replace. Oh, sorry, the pattern apply the result. And then we return the final result. That's the object-oriented structure that we have. Now we need to combine these rules as a tuple that we're going to execute in our parse rich text. So here we already have the scaffolding for the parse rich text function. We have the rules. Here, instead of any, we can use t-rich text rule. And it's the same thing. So we're going to use the rules and then reduce, use our accumulator in the next rule. And then we're basically calling the next rule and apply our text. So this will execute all the rules and return the resulting text. So now let's build all the rules, which we can export later and use. So first of all, we can. It's a good approach to replace the most specific things. For instance, the link is quite specific. Then we have the. So let's create a new rule. New text rich t-rich text rule, and then we can call this rule link, and then we can pass the new pattern. So now we create a new rich text pattern, provide the replacer function, provide the regex for the link and replacer. And I think the link is a tuple that we can use. Let's see, link. Yep. So, and we need to repeat this process with all the available regular expressions that we have. So let's insert the view. Now let's build the headers. Here we start with the header 5 and header 6, and we duplicate this line multiple times, and it's 5, 4, 3, 2, 1. Now we have all the headers inserted into rules. All right, and the next thing is the table. So let's create the rule for the table. So we're creating the pattern and assigning it to the rule. And the next thing is list, paragraph, and our formatting. So list. So here we have two lists, one unordered and one ordered list. And the next in line is the paragraph and the basic formatting. So let's do the paragraph rule now. and then we're creating the new pattern, and then apply the paragraph rule. Okay, so we're almost done. So the next one will be is the last one, which is the basic formatting. So we're creating a new rule. Here it should be a rule as well. And let's call it formatting. And now we need to create the pattern for each format that we have. So this is the bold, italic, and strike through. That's the engine system that now we have. So we basically, our engine have all the rules and the patterns to parse the text. And if we try to execute this through the parse rich text, so we can see the output. So for that, let's go to the website. And here you'll find the Markdown and student.react. Let's refresh. And we won't see any value. That's because we don't parse in anything right now. So let's get back. So let's open the project structure. And here we have the Markdown file. And let's just implement the Markdown parsing real quick. So we get the text. So this means that what we can do, we can call our parse rich text function that we built. And then we provide the source text as an input and the rich text rules that we just built. And let's import this as well. And here, we can, because we're building our own Markdown engine, so we know exactly how it transforms the structure, so we can kind of skip the security checks. So let's remove these comments and go the easy way. So we know that the result is going to generate the HTML. So we can set dangerously inner HTML, use the HTML property. That's actually how the Markdown libraries work. And pass the result. Ideally, you want to sanitize the input before you parse the Markdown. But usually you use the custom sanitization libraries. It's not something that you need to implement on an interview. Let's see why it's complaining. Okay, we need to ignore, suppress. Okay. Let's verify that it works and it's not just a type issue. Okay, and it's now failing. Let's see why. Dangerously set inner HTML must be in form HTML. Let's see what is wrong here. Which one should I use? 1/ or /? Okay, end result. Let's refresh. Okay, it's just one. It's just one. Okay, let's go. Yeah, now it works. And our Markdown is parsed. As you can see, we have some bold text, some basic formatting parsed. We have the annotated list that we entered as the Markdown. Now we're able to parse the links and the tables. And that's the core of the ChatGPT engine. So you will see that the ChatGPT itself is just a Markdown engine that runs once we get the data from the server. And our next step will be to connect to build our own ChatGPT client that will use our Markdown engine and then parse the data from the server and dynamically render the values. Do we have any questions from the room? I know that that problem was actually quite hard, and but I think for you the most critical part to understand is how the ChatGPT works after all. So you don't need to know how to build the full-fledged the Markdown engine. But once you build it, you know that it's actually no magic. It's very easy to re-implement. Do we have any questions?
Yes. So you follow the OOP structure. So was that only because of a requirement of the interview, or would is it common that they ask for other patterns other than OOP to solve this kind of problem?
Oh, you can build it whatever you like. So I just used it because for me it made sense structurally. Okay, so let's go back to the slides. So we built our Markdown engine. So we're one step ahead. Now the next step is to connect our Markdown engine with the client. So the way it's going to work, that our server will stream the text in chunks. So this means that we cannot render the whole thing in chunks. So there is a typing effect, and I'll show you how it looks. So if we open the GPT client and then reference solution, and then we can type something and click send, you'll see that things are rendered using the chunks. When the chunk arrive, we kind of creating the typing effect and slowly typing the chunk. So we do not exhaust the chunk immediately. Okay, so the way it's going to work, we receive the chunks. So the chunks can, depending on the server, we can receive chunks faster than we can exhaust them. So this means that we take the first available chunk, and then starting to appear the text. And we can append the text using the just maybe this short slice. So for instance, we take the chunk which has the length of 100 symbols. So what we do, we take the first two symbols, append to the main state of the chat, and render this. Then we schedule another callback to get the remaining chunk, and slice another two symbols, and that's how we create the typing effect. And we continue this process until we have any chunks left in the state. And that's it. That's how the chunking is implemented on a client. In terms of what is provided to us, a few things that we already have with this exercise is the hook that's called use Markdown stream. And this Markdown stream connects to the mock server. So there is a real server that sends the binary data to us. And it has three main options. The callback on complete, the callback on error, and the delay. The delay is basically to tell the server how much time we need to have before the next chunk arrives. This is just for testing purposes. Okay. The only thing that we will need to use to implement the chunking is just onComplete method. So we're gonna send the request and we'll start store all the chunks. So let's jump to the code. I think once we code it, it will be more clear. So open the next file called GPT client, and we're gonna use React again, and let's start coding. So first of all, we'll need to use our Markdown stream. So let's go use Markdown stream, and then it will output two functions, stream and abort, in case we want to stop sending receiving the chunks. And the third field is in progress if we're still receiving, if we're connected to the server and receiving the chunks. The next thing that we need is the state. So these are the chunks that we'll receive from the server. So So we'll call it as useState, and then it's going to be a string array. Each chunk will be just a single string, but because we store multiple chunks, we use the string array. And then we're going to have the content so that we already rendered. So this will be the content and set content. This will be just a normal string that is appearing on the chat interface. And by default, we will start with empty. Okay. So now let's implement the UI. So we need to have the input area and the chat area. So this means we'll have two boxes. So one box is just a section where we'll output our content. And the second box is the text area with the button. So let's create this one as well. So we'll have the text area and the button. Which will send the request. Okay. Now let's get the basic styling done. So we're gonna use a very simple grid style. So let's apply the CSS class name, and we already imported the module CSS, which has the name CSS. And then let's apply the chat. So our section will have the class chat content, and our another section will have class chat controls. Okay, and let's add the basic style. Chat, display grid, and let's create a template how our rows should be structured. So grid template rows, and now we can define how much space our rows should take. So the first row will take one fraction, which means that it will take the most available space. And the second one is the 200 pixels. So the chat content, let's have a border on this one to separate this. 1 pixel, solid black. And the chat control, let's also separate this. And have the border as well. And maybe let's make it flex with the row direction. And center alignment. Okay, let's see how it looks now. So let's go back to our web app. So open the student.react, refresh. Yeah, it's kind of weird, but let's see what is wrong with that. So we have our section, and this is the chat content, which doesn't take space. So I think by default, what we can do, we can force this chat content to take 100% of the space, and also the chat itself to take the 100% of the available container. And let's see if it helps. Refresh. Okay. Now we have our text area, which looks a bit weird. So let's also quickly fix that as well. So our text area has the property called lines, I think, or do you guys remember the name of the property to control the number of rows? I think it's just rows. Yeah. So let's make it 5 rows. And okay, let's keep the style like this. So for now, let's focus on the logic. So now we have our area where we appear the text. We have the button that we'll click to send the data. And let's handle the data sending. So let's create a function called handle send. Handle send. And what it does, it just start the streaming. So now we call our stream, and then we pass the on chunk event here. So if we receive the chunk, and the data will be here, then we need to update the state. So our stream itself, let's see what's the signature it has. Our stream callback provides just a single chunk as a result. And then we can set the chunks. So we use the previous state and append the chunk at the end of the array. So now we're able to populate all the chunks. And here in the handle send, so we create onClick event and then handle send. So now let's see if the chunks are appearing in the state. So console log chunks. So refresh. Okay, we don't get any chunks. So let's verify that we are correct. Here on stream, console log chunk. And let's hit refresh. Oh, it's because we haven't sent the message yet. So let's click. Now, see, we get our string chunks, and now we need to process them. So these chunks are done in the Markdown, so we need to first parse it as the HTML, and then append it. And the way it's going to work, here's our content. And we're going to use our Markdown component, Markdown, that we just implemented. So let's replace our here. Let's import the Markdown component that we have. And it accepts the text and the content. Okay, so now if we refresh, nothing as well should happen because we are not appending this. So now let's implement the function that will take the chunks and start appending this to the to our Markdown. So for this, we'll create a function called type, which will mimic the typing effect. And then it will accept the chunk. So if the chunk is empty, so this means that we exhausted it. Then we need to what we need to do, we need to get another chunk from the state. So we are now calling, we're now getting another chunk, so new chunk. So we calling the state, we're using our chunks. So let's first clone the state. So this is our chunks. And get the first element. And then we access the chunks and say we're just getting our first element from the array through the shift method. shift, and it will give us the first element. We also need to verify that the chunk's length is more than 0. And we need to restart the typing effect with the new chunk provided. Okay, so now if the chunk is not exhausted, what we need to do, we need to slice this chunk. Here we're going to slice it. And let's say we want to we want to type the content with the speed of 3 symbols. So we're going to use slice 0 to 3. So to get the 3 symbols, then we use the set content, and we append this slice to our content. And the next step is to schedule. So in order for if we do it like this, then if we have lots of chunks and we execute too many times, we're gonna load the main thread and our UI will not be responsive. So for this, we're gonna use the special method that allows us to set the schedule the event in a available time between the frames. This is called schedule set. Forgot the name.
Is this the animation frame?
Yes, set animation frame. Request animation frame, actually.
Yeah.
So what request animation frame does, it ensures that our callback is executed between the animating the frames, so we don't block the main UI rendering thread. So we're requesting the animation frame and pass our and return our, and again we recursively call the type constant and then pass our previous chunk. And then we slice it, we substring it, just slice 3. So this means that we're reducing the chunk size, so we're basically cutting the first 3 symbols. That's the idea. Okay, so now let's see if it actually works. So here, the remaining thing that needs to be done, we also need to set the state. Set chunks, and it will be our clone. Okay. So now we have the type function, but it's not really executed yet. So this means that when we receive the first chunk, we need to start typing. And we need to create a new effect. So when we receive the new chunks, so we'll be able to execute the typing effect. So let's create another effect called useEffect. And then we have a dependency on the chunks. And now we want to check if one thing we also need to have is another Boolean field. Once we start typing, we need to set a flag as typing. So we don't, if the chunk is updated, we do not re-trigger the typing. So let's have another constant called isTyping, and set typing, and by default it will be equals to false. And here we check if we're not typing, then we need to start typing. That's what we do. Type chunk. Zero. And actually we can just pass the empty string, so the type function will automatically pick up the chunk from the state. And we also provide isTyping. Okay, and what else? And once we finish the typing here, we can have the condition if the chunks length equals to 0. This means we exhausted all the chunks. So we set the chunks to empty, as well as set typing to false. That's the type function. Let's see if it actually works. Let's go back to our UI, refresh the page, and you see we have some loop in the use effect. Let's verify that it's correct. So let's remove the dependency here. So okay.
So you never set isTyping to true.
Yeah, that's true. So let's do this. Set typing true. Okay, and let's verify the logic real quick. So here we're setting the chunks, so the chunks are arriving. Now we're starting to receive the chunks here. And inside our type, I think we also need to memorize this, because otherwise our use effect will be called every render. So let's put it inside the use callback. And it will depend on our chunks. Okay, and let's see why it's complaining. This is because we're trying to wrap it and then call it again. Let's first extract it as a function. Const type equals to function. And then let's place it here. Type. Okay, and now we need to memorize this function. No, actually, let's see if we can do better. So we have our function type, and when we handle send, we can potentially start typing here. And then we receive the chunks, and then we start typing. So let me check how it works right now. So do we have a loop? Obviously we have a loop. So if we send it something, then okay, nothing happens now. Let's see. So here we'll set the type into true. And let's remove the set type in here. Okay. And let's see what is happening now. Okay, we see that now our effect is executed multiple times, so there is an issue with the way we set the state. This is most likely because the type, when we call the type function, we also modify the state. Okay, let's see. We set the set type into true. And let's debug the code to make it clear. Put the debugger, refresh the page. Oh wow, at least it starts rendered. Oh yeah, now it's just, even if you just refresh this thing. This means that it just goes somewhere here. So let's open the source file. Yep. So here's our empty chunk. Oh yeah, so on empty chunk we always set an empty array. So let's verify that we don't need to do this. Let's refresh. Send. Oh wow. Let's see. Let's put a debugger again. So again, we start with empty string. So if the chunk's length is equals to 0, then it's false. And again, because it's false, we're again starting to type. And we need to have one more check here. If chunk's length more than 0, then we should only start typing. So let's reset. And again, let's also debug on the effect and type function to see what's wrong. Send. So typing is false. Chunks. So we have one chunk in the state. So let's dive in. So we set type into true. Now we start typing. We enter the type, and here, since we have the empty state, we get our first chunk. Here's our first chunk, and now we're starting to type the first chunk. So now our chunk is set. So this means, okay, why? Okay. We should also add the check here. If our chunk length is equals to 0 as well. Okay, so if we refresh the page, so let's disable debugger for now, enable it again, type something, and then let's send it and see if it works. So we're setting the status type as typing, then we enter the chunk, our chunk is empty. So we access our chunks, get a new chunk, go inside the type again, and then yes, we get the right statement. So we get our chunk, and then we slice it. setting the content, and request animation frame. The only issue I see is here when we recursively call the type, we continue with this frame, so we need to return here if this is the case. So let's return. Okay, it's much better now. So I think we're almost here. So let's go and send. Oh yeah, we solved it, almost. So I see there is an issue with, it's almost parsing this, but this just means that somewhere we're, okay, here again, we need to return in this statement as well. So let's do return. Let's refresh and send. It's better, but something's still wrong. It feels like we're duplicating the chunks. Let's refresh and debug it a little again. So let's verify what is wrong. So probably there is a, also we need to set isTyping as a dependency. Okay, so let's put a debugger, refresh, send. Oh, I forgot to enable debugging. So let's refresh again, send. So we're starting to type, we get our chunk, and because the chunk is empty, we get in our first chunk. This is a new chunk. And we call the set chunk. Okay, I know what's the reason. So we need to set chunk before we type again. So let's do this. Refresh. Let's refresh the page. Send again. Debug it. Type. So here we're getting our first chunk. Then we set the chunk to the empty array. So chunks, shift. Oh, okay. There is another issue. So we're cloning the state, and we're basically returning to the same what we had before. So let's fix that as well. So here, instead of chunk shift, we do the clone shift. So let's refresh again, and just for the sake of test, let's just verify. Maybe it's working already. It's all, yeah, it's just the outputs the first chunk. Let's see what's wrong. So let's refresh. But we're almost here. Send. Debug. So we get our first chunk, which is a chunk, and then the clone is empty array. So we set chunk to the empty array. Now we type a new chunk, go inside. So our chunks, okay, I know what's going on. So the thing is that the chunks itself is not yet updated. So the state, when the state executes, it hasn't been set yet. So that's why we're still getting the older state. And the only way to fix this, I think, is by doing this. So we use so instead of this, we use the set chunks. let's see. So here we get the older state, the chunks length. And we want to make sure that the type will have the new state. Let's maybe think about our approach a little and see if we can optimize it. So instead of calling the set of the set state like this, can we update our state and then okay. Probably we can migrate a little bit of our logic. Instead of the type handling the state, we can move it to the use effect here. So if it's not, so let's change the logic a bit. So let's simplify the type. So every time we're updating the chunks here, and we are outputting the new chunk. And then we have the set content and request animation frame. So the group, what do you think? What should be done? I think we're missing a very small bit here, just a very small, and the issue in the code. I think somewhere here. So this is the problematic place that we have. So when the chunks is
because so when we come back to type, chunks is not changed because you're calling shift on the clone.
Yeah.
And chunks is not changed inside that.
Yeah.
Inside that block.
Maybe
So-
we could. Oh, sorry.
No, I'm just.
Maybe we could put some logic here inside the use effect instead, and then the chunks is updated, then we execute the type on the chunk. So maybe let's try to change the approach a little. So here inside the use effect, if we not typing, and we have some chunks available, then we're gonna pass the chunk. So here we update the available chunk, set chunks, then we use the state, and then we cut the last chunk from the state. State, slice, like this. And then we call our type. So here we access the chunk 0, pass the chunk. So let's see why it's complaining. It's because we're updating the state within the, that's okay. If chunks more than 0. So now we should be able to type. And let's change the logic. So if we exhausted the chunk, then we set the type into false. And we can remove this check as well. And our use effect will be responsible for providing us with the chunks instead. And here we just return. And then we call the if if it's not the case, we call the slice, then we set the content and request an animation frame to process the chunks. Okay, let's see if this approach works. So let's refresh. So let's send something. It almost works, but not really. So let's, but I think it's now almost correctly writes the stuff. So it's more like maybe we just processing the string incorrectly now. So let's see what's wrong there. So we could put the debugger again.
Are the chunks, are they guaranteed to be valid chunks? Like it's not going to split?
No, it's guaranteed to be valid. Yes.
Okay.
So let's use debugger here as well. Refresh the page and send. Oh, sorry. Let's refresh again. Send. Okay, so let's go to our debugger statement now. So this is the chunk, and we're so let's see if the slice one is actually does what we need. Slice one. It's because we're not within context probably. Okay, set chunks. Let's just verify that it actually removes the element. Slice one. Yeah, so I think it works. We go inside. So our chunk is not empty. So we slice it. So the first three symbols. And then we pass the previous to the slice. So the previous is basically nothing. And then we need to verify that chunk slice is the right statement to execute. Let's see. And I think we're a bit more wrong. So let's see. Let's go back to the source again. So we need to cut. Yeah, I think it works as expected actually. So this is the remaining part of the string. So let's now traverse back. So we type again. So now there is a remaining part of the chunk. And again we slice. And then append the previous state. To the content. Request animation frame, state. So now it's parsed U. I maybe have a feeling that we might our solution to the Markdown parser might be also wrong. Maybe we made a mistake in the parsing engine. So let's just quickly exclude this from the equation. So we can quickly import the solution one. Okay, use Markdown stream, and instead of importing the one that we've done in the previous exercise, let's import the solutions Markdown. Okay, and let's refresh the page. Type something, and then send.
Almost, but not quite.
Almost, but not quite, yes. So I think it's just making little mistakes here. So it's even parsing the table correctly. So something little is wrong, just a little. And let's see. So if it's not typing and the chunk's length, then we execute our chunk. So we get the most recent chunk. Oh, let's also rewrite it a little. So let's use the set chunks and get the most recent state. Then let's get the chunk to execute. And then here we'll call type, just to exclude that maybe the state is not correctly, with not getting the most recent state. Type chunk. Okay, let's refresh the page again and query. Nah, made things worse. Let's continue debugging a little here again. So let's also verify that we set in the chunks correctly. So we set chunks, the previous, and also the next chunk. This seems to be correct. Let's put another debugger statement. Send. So here's our slice, which is processed correctly. We set the content of the slice. And then we request animation frame to do another, to process another type. And our debugger died for some reason. Almost done, almost done. Let's kill the page. One thing that we might missing here is when the chunk is updated and we're still typing. Yeah, it should not be an issue in this case.
Can you do a console log of what right there? Console log prev plus slice, so we can see what's going on there.
Yeah, we just validated this. It's actually slicing correctly, but let's see the first call. So the first call parses. Oh. See, it's okay. Now I know the reason. Here, I removed the animation call. I removed the call, request animation frame, and now the call type. So the use effect execute type, and it continued to type things. And this is because we need to set the type into true. Set typing true. Let's refresh. So now the only single chunk should be outputted. That's correct. And it works. Feraspera and Astra. So we debugged the whole thing, and the only reason was that we're kind of duplicating the call, and we didn't set the set type into true in the use effect. That was the reason. Congratulations. That was a painful one. Okay, so let's recap. We fetched the chunks. Then we created a type callback that consumes the chunk, and a use effect that fetch the chunk and execute the type effect. And that's our simple JSX. And one thing that we haven't done yet, see, we are losing the scroll position. So in order to fix this, and it's a very simple fix, we need to get the reference, the container reference. And use ref, pass the HTML div element as the type, and then we connect our main container, which is this section, reference container ref. And when we change the content, we just manually scroll into the container. So here we set the content as a dependency. And then we use our if the container reference is current, then we basically assign the scroll to the scroll height. So we always at the bottom of the container. So let's refresh and execute. And now we should be able to scroll into the container. Oh, it doesn't work because we haven't set the overflow on the container itself. So our chat content should have overflow scroll overflow y. So let's refresh and see if our container changes. And now see we have the after scrolling, and our content is automatically goes down. That's our shiny ChatGPT interface. Okay. Yes.
So the typing code that we added in there was just to simulate ChatGPT's response back to us, right? Because ChatGPT chunks responses. So I was thinking that this would be a good application for a generator function, where I just call to get the next 3 characters.
Yep.
And then we could have hidden all that complexity inside the generators.
Yeah, I think it's a good idea for the type function. Yep.
Okay.
Okay. So before we jump to the last problem, which is the Google Sheet, and it will be our boss problem. So do we have any questions on the last one in the chat?
Just a comment that it's impressive to see you keep composure, focus, and debug without, getting emotional or when things go sideways. It's like a class of its own.
Okay. So let's have the 5 minutes break, or
right.
maybe 7 minutes if possible, and then we'll come back. All right, so ready for the final boss problem. So this is going to be the most complex problem we solve for the whole workshop. So it will feel like the previous problems were super easy. So yeah, and I expect that we'll have to debug as well because it's very hard not to make a mistake in such complex problems. So the next problem is the Google Sheet. So we're gonna build the simple clone of the Google Sheet where you can enter the formula in the cells and also we'll parse the values. We will have the limited number of columns, so the columns that we can have is A and Z, and the limited number of rows. So for this exercise, we'll probably just limit the rows to 50 because it doesn't really make any sense to increase it to 500. And each cell will have the unique identifier. So this is done the same as in the past. So it will be A1, B20, B25. So you basically have the column ID and the row ID. So also the features that we need to support is addition, subtraction, multiplication, division, the parentheses for precedence control, and we also need to support the references. So your cell can be constructed with the multiple cells. For now, we're going to limit the values to the numeric values only and the text values. And yeah, that's what we're gonna do. So a few things that are already provided to us, because this is not algorithm course. So we're gonna have the AST builder, which parses the whole formula and constructs the abstract syntax tree. I don't want this course to be algorithmic heavy, and I don't think that there is a value in knowing textbook algorithm on your interview, because most likely you will forget it anyway. So, and asking the textbook algorithms, I think it's not reasonable. And also, we'll have one thing which converts our tokens into the reverse Polish notation. What it does, it basically takes our tokens and orders in the execution-friendly order. So the reverse Polish notation is used when you're evaluating the expression in the format of the stack. And it's another textbook algorithm that I don't want you to know because once you can learn it from a textbook, but there is not much value from this. These are two things that will already be provided, but it doesn't make the problem simple, and you will see why. So, in order to solve this problem, we need to decompose it. So, and again, first we need to have an engine that will drive our UX. And if we start thinking about what's needed to be implemented, so as you can see, imagine that from UX we have the formula, which will be the following. So the B1 will be equal to A1 plus 50. So in order to start start calculating this, we need to store the raw value inside the state of the engine for this cell ID. So this will be our raw value. Next, we need to create the state for the future computed value. This will be the value that will be compiled and executed once we have the formula parsed. Then we need to know the dependencies. So if we're modifying the B1 cell, what are the dependency of the B1? In this case, it's A1 cell. So in the future, we also need to validate to check if A1 is also changed. And in order to track the changes on the dependency cells, we also need to have the reverse dependencies. So imagine that you're recomputing the A1 cell, and there are multiple cells that depend on this A1. So in this case, we can have the reverse dependencies maps to see what are the cells that depend on the A1. That's why we store in our map, which we will call the reverse dependencies. And this will be our engine state. Then we need to compile the formula. So the formula will be tokenized. So we'll do the AST transformation. So basically we're extracting the tokens. So for instance, each bracket, each operation sign will be separated as a separate token. And once this will how it will look like. For instance, the A1 will be so we'll create a token called with the type reference and ID A1, and then for 50 it will create a token with the type number, and then the value will be 50. And for the operations, we'll create a token with the type operation, and the operation value will be plus. That's how we split the things. And this is done inside the provided tool called Tokenizer. So you can see the implementation inside the repo. So if you're interested in, but it will not be a part of this exercise. Then we have all our tokens, but we don't have the correct order of the execution. So for this, we need to there is an algorithm called reverse Polish notation, which sorts the token into the stack-friendly notation, so we can execute it later. So this will sort the token in a special order, so for later to compile. So we'll store this reverse Polish notation into the compile field of our state, so we can later evaluate this. Once all the fields done, so we now need to understand the dependency order. And in order to construct the correct dependency order, like in which order we need to evaluate the cells, because depending on the dependencies on other cells, we need to first execute the cells that have no dependencies, and then continue with other cells. So for this, we're going to apply the topological sorting. So for instance, as you can see, if B1 depends on A1 and A1 depends on C1, then if we sort it topologically, we'll get the C1 to be executed first, then we get A1 to be executed second, and then B1 to be executed next one. So this is the topological sorting, and we're going to implement this topological algorithm. That's the only algorithm in the course that we're going to try to write it down ourselves, because I feel like the topological sorting is actually quite useful to know, and it's not very hard to implement. And next, we basically take an order of the cells, and then we'll execute the evaluator. So we take the formula of every cell, and in topological order, we'll execute the evaluator of the reverse Polish notation. So this is also a provided tool, so it just reads the RPN and gives us the result value. And then we update the computed value within the engine state, and then we pass it to the UX. That's the overall how it's going to work. So any questions for this picture?
So, are you considering there on the dependency order recursive references? So if A reference
Yep.
B, okay.
Yep, that's why we need topological ordering. So we're going to use the CON algorithm, and it also handles the cyclic dependencies as well. Okay. So now, let's just do it, right? So let's move to the code. So our first step will be to build the basic class structure, like all the maps that we store and so on. So it should be relatively easy exercise. So let's move on to the repository. So you need to open the Google Sheet Basic, and then they open the, not the solution, but the table engine.ts. And the exercise is very simple. Let's just construct all the fields that we'll need in the future. And the first field that we need is the map where we'll store the row value. And it's going to be the map of the cell ID. And the cell ID, it's the provided type. Essentially, it's a utility type which has the following structure. I'll show you in a sec. So the cell ID just tells us that the first letter is the string and the second letter is the number. So because we have it's just making the string type more narrow, I would say. That's why we providing it in this form. Okay, so the next is the value. which also the map of the where ID is the cell ID and the value is the string. And then there is a dependency. So the dependencies is essentially, if we have a cell, what are the dependencies of this cell? These are direct dependencies. It's going to be the map of the cell ID. And then we're going to have a set of the cell ID as a dependency. And then we have the reverse dependencies. The reverse dependencies are needed when, for instance, you have the cell B1 and you're recomputing the B1. But you know that there are other cells that depend on B1. In this case, to get all the cells that depend on B1, you access the reverse dependencies. And then later, once you recalculate the B1, you go through the reverse dependencies and recalculate the reverse dependencies as well. And we're going to need one more field, which is the compiled. So the compiled is just the map, which will store the compiled reverse Polish notation inside the map. And we have a special type called compiled. And if we check what it is, it's just it can have two types of value. It can be null in case of the just the simple values without formula. Then it can have an error. In this case, we need to print an error within the cell. And then it can receive the tokens as a reverse Polish notation. So the token can be num, reference, left parentheses, right parentheses, and the operation. So an operation, all the operations are here. OK, so now let's initialize it. So nothing complex so far. So now let's create getters and setters. So when we initiate this, when we create this, call the set row, we are setting the row value inside the formula. So here we update our map. So setting the ID and the row value. And also for now, we don't really care about the value because we don't compile it. So we can set the value as well as the row value. OK. And now we just return the changed IDs. So because we know that we changed the ID, we just return the changed. The set row itself, when we set the formula, we return all the changed cells for the UI to update later. So for now, we just return one cell. This is just basically a stub. It doesn't do anything. So let's implement the getRow function. So we're going to refer to our row map, get ID, and if it's empty, we return empty string. And same thing happens for the get value. If it's empty, with an ID. If it's empty, then we just return empty. That's it. So nothing hard so far. Now, the get dependency should return the set. In this case, let's get our set. If the dependencies get ID has our set, we return the set. Otherwise, we create a new one. And then we just, if there were no set, we just set it. And we return the set. Same thing for the reverse dependencies. So let's copy it over, called reverse dependencies, get ID, new set. And also here, use the reverse dependencies. That's it. We completed the first of the 6 parts of the exercise. So just getters and setters. So for now, nothing complex. let's jump to the next exercise. So we've done this. Our next step is to do this. Now you have an input. We need to do something with this. Oh, by the way, I forgot if there are any questions in the room on the previous exercise.
Can you go back?
Yep.
Yeah, so you've got a getter, right? A get deps and get reverse deps,
No. Yeah.
but you're setting state inside that getter. Is that? I would flag that as
Oh yeah. So the thing is, if we're trying, because we by default initialize. By default, we do not initialize the sets for all the dependencies. So for all the cells, because if you have 500 cells, you don't want to initialize 500 sets. So here we kind of do the lazy initialization. So we assume that by default the set is empty. So if there is no set for this ID, we just pre-initialize it and return the set. That's the overall logic for this getter.
okay, makes sense, but okay.
Yeah, I know it's not like sounds like orthodox where we initialize the set within the getter, but we can. Other case, you would need to have a separate method or function to initialize it, and it would make things more complex.
Okay.
Okay, so now we are ready to jump. Okay,
Only
Mark.
quick question. Reverse dependencies will be used for propagation of change. What dependencies will be used for non-reversed one?
So the reverse dependencies will be used when we actually do the topological sorting to get the cells updated. If we're recomputing the cell and there are dependencies on the cell, then we're recomputing the reverse dependencies. But the direct dependencies, it's basically the dependencies inside the formula. So we need to compute them, and we're going to compute them once we set the formula because we're compiling the formula with direct dependencies. And I hope it will be clear once we go to the compile part, and it's the next one. Okay. So now we have our row input. We just basically set it in the state. Now what should be done with it? So first, we need to check if our input is a formula. If it's not, we don't change any cells. This means that it's just a raw value. And we just need to return set. So the compilation step should return the sets, the cells that have changed, so we can execute topological sorting over them later. And if it's the formula, then we need to tokenize the formula. We will call the tokenize. And if there is a tokenization error, we'll store this error inside the state and return non-empty set of the changed values. Then we try to convert this into the reverse Polish notation. And if there is any error, we again store the error and return empty set. And once we return the dependencies that were inside the formula, we'll need to set these dependencies into the state. So let's try to build this compile step now. Let's jump to the code, open the 58 Google Sheet compile, and it will basically start off from where we stopped last time. So here, we have the method called compile. And now we are ready to execute on our row value. The first thing that we need to check if the row value is the formula. And the formula always starts with the equal sign. And if it's not starts with equal sign, this means that we need to return the empty set of changed values. So let's create the changed. So let's call it maybe dependencies new set. Return dependencies, and we will store null value into the compiled part. This compiled set ID null. This means that there is it's not a formula, it's just a simple value. Okay, now let's extract the tokens. So we create a variable called tokens, and we have the special method called tokenize which is provided to us. Then we pass the raw value, and we need to slice the equal sign from it, so the tokenizer can correctly parse the tokens from the formula. So now we have all the tokens. We need to check if the tokenization step hasn't failed. So we check if tokens. Okay. So the tokens returns the following results. So it can be OK and the tokens available, or OK can be false and the error will be available. That's the union that it returns. So if the tokens were not extracted, this means that there was some compilation error. So there is an issue with the formula, and we need to store this error. So we set the compiled to the of the cell ID to the error, and then we pass the tokens error. Okay, so now we need to convert tokens into the reverse Polish notation. So let's create a variable called RPN, and then we have the magic method that converts this to the reverse Polish notation. So, and again, the implementation of both of these functions is available in the repository, so feel free to check out. So let's see, here is our tokens, and inside we should have tokens. So TypeScript is complaining that there are no tokens there, but I'm pretty sure they're there. Let's verify if tokens not okay. Okay, actually it returns RPN. Okay, so we have the RPN now, and if the RPN failed to parse, so it's also not okay, then we're going to store the compiled error. Set ID, we can actually just copy this thing and use RPN error here.
So
Yep.
to fix your error on line 91, just above there you should return.
Oh yeah, that's correct. We forgot to return the empty dependencies. Return deps. Thank you. And here the same case. We need to return the dependencies, which will be the empty set. Okay, now we have the reverse Polish notation compiled, so we need to store it inside the compiled method, in the compiled map, sorry. Then we set the ID, and then we set the rpn.rpn. So now we need to extract all the direct dependencies that were used inside the formula. And in this case, we just need to iterate over the tokens. Token of the rpn.rpn. And then check if the token type equals to reference. If it's a reference, this means that it's a direct dependency. And we populate this dependency deps add token ID. Okay, and as a result of the compilation step, we return all the dependencies that were changed. And we're done with the compilation step. So the next step is we need to tied everything together. But before, so the compile step will give us the next set of dependencies. This means that we also need to update the reverse dependencies, because we also have the reverse dependencies that were set previously. So for this, when we set the dependencies to the next dependencies from the compiled, we need to first get the previous dependencies, verify that these dependencies do not exist in the next dependencies, and remove them from the reverse dependencies. So let's move to the step, and I'll explain. I think I have a diagram actually to explain it. So here's an example. Imagine that the previous formula was A1 equals to B1 plus C1. And the next formula is A1 equals to B1 plus D1. So the A1 direct dependencies is B1 and C1. And if we try to construct the reverse dependencies, then we know that B1 depends on A1 and that A1 depends on B1 and A1 depends on C1. So that's the reverse dependencies that we're storing. But with this next new formula, now we have the old reverse dependencies set up. So we need to so the A1 doesn't depend on the C1 anymore. So we need to remove it from the engine state. That's the idea of the next logic that we're going to write. So removing, cleaning up the state and adding new dependencies if it's required. Okay. For the setting the dependencies, we're going to iterate over. So first of all, we need to get the old dependencies. So let's call it previous dependencies, and we're going to call this get dependencies, and provide the ID that we're setting. Now we're going to iterate over the previous dependencies, old dep of the previous dependency. And now we need to check if the next dependency doesn't have the old dependency. So this means that we need now to update the reverse dependency. So we get the reverse dependencies of the old dependency, and then we remove the current cell from the reverse dependencies. Is it delete? Yeah. Okay. Is the step clear? So we removed the old dependencies from the reverse dependencies of the cells. And now we need to add new dependencies. So that will be the next loop. So we're going to iterate over the new dependency of the next dependencies. And if the old dependencies doesn't have it, then we're going to get the reverse dependencies of the new dependency and add the current cell as a reverse dependency. And I know it will take a while to wrap your head around this, but the logic is actually pretty simple here. Okay, and now we just set the new dependencies on a cell, ID, next dependencies. That's it. Now let's connect everything together, and inside the set row value here, we need to call the compile. So we call the compile. we pass the ID, and we pass the raw value. So the compile will return the set of the dependencies. And then we're going to execute set dependencies and set them. And for now, we're just, again, returning the step value here, so it doesn't do much. That's it for the compilation step. And let's see on a diagram where we are. So we've done the following. So we implemented the engine. Now we parse the formula. We create the RPN. We store the compiled values. That's it. So nothing else happening. So our next step will be to execute the topological ordering of the values. Before we jump into the topological ordering, do we have any questions in the chat or in the room? If it's clear, let's go ahead. All right, so the topological ordering, how does it work? Imagine you have the spreadsheet, and now you have the few values inside. So you have the value A, and then the B depends on the A, and you compute the B. And then you have a C that depends on B, and you multiply the value by 2. What is the correct order to execute this? That's what the topological sorting answers. So first, ideally, we need to check the A1 because it doesn't have any direct dependency. Then we check the next value, which is B1. And then we check the next value as a C1. That's the correct ordering evaluation, and that's called the topological sorting. So if we face a cycle where the A1 depends on B1 and B1 depends on A1, that's the error because it's the loop. It's basically a loop. So in order to perform the topological ordering, we need to use the Khan algorithm. So what it does, it first constructs the. So first we need to get the reverse dependencies. As you can see, our reverse dependencies is the following. So we edit A1, and at the current state, our reverse dependencies that the reverse dependencies of A1 is the B1, and the reverse dependencies of B1 is C1 because and we need to construct the set of affected nodes. So we basically take all the we need to create a set of all the nodes that we need to recompute. And that's why we're going to use the reverse dependencies. Then we're going to construct the in degrees map. It basically tells us how many direct dependencies the cell has. So for instance, A1 doesn't have any direct dependency. But B1 has a one dependency. It depends on A. And the same thing on the C1. So we construct the in degree map, which is basically a cell ID and the number of direct dependency. Then we start to process our map and the cells. So first, we always start with the cell that doesn't have any direct dependency, which means that should be first, and it will be the first element. Then we take the A1 and see what are the reverse dependencies. What are the cells that depends that A1 is used in? And we see that it's a B1. So B1 is using A1. So B1 has a direct dependency on an A1. So we're processing A1. And since we process this cell, we're going to reduce the in degree value by 1 and kind of removing this edge because we already processed this edge. Now, next step, we're checking what are the dependencies of the what are the cells that depends on B1. And in this case, we get the C1 because C1 is using B1. So we're processing this cell as well. So the B1 becomes the second element in our order, and the C1 is getting processed next. So we're processing C1, reduce the in degree count, and the C1 will be the second element. So that's how we construct the ordering. And if we change the graph, how the graph is positioned, you will see that's the A1, B1, and C1 graph now. Any questions? Okay, so now let's jump into the code and implement the topological ordering. So Google Sheet 59 Topo. Here, it's basically what we had in the, from the previous problem and a few more methods. So first of all, we need to get all the affected nodes. So from the formula. So let's create a set and call it affected. And we know exactly from which cell we always start, because when we modify the value of the cell, that will be our starting set. Let's create also a queue and push the start inside the queue. That's our starting point where we start to iterate. Then we're going to loop through the reverse dependencies. So first we're going to loop through the queue. And then we're going to loop through the reverse dependencies. For get reverse dependencies of the cell. And now, if the affected doesn't have the this dependency, so we want to push this dependency to the queue to also check the reverse dependency later, and we also add this to the affected cells. So add affected dependency. And then we're going to return the affected set. That's how we get all the affected cells from the formula. Now, it's time for the to implement the topological sorting. So we get our affected cells from the previous call. For now, we'll call it later. And we need to loop through the through our affected cells to construct the in degrees. So let's create the map called in degrees, and by default we initialize it as empty object, and it's going to be a record of cell ID and number. Now, we'll loop through the affected cells. And then we will pre-initialize the in degree for every affected cell. So we're going to use the following operator. So this will basically initialize the in degree to 0 if there is if the value was not assigned in the past. Okay.
Oh, I like that.
Now, we need to calculate the number of the affected cells. So here, if we go back to our slides, the in degree will be the following. So we process all the dependencies, and we verify and we take all the direct dependencies of the cell and assign the length of these dependencies to the in degree. All right. So now we loop through the direct dependencies, direct dependency of this get dependencies of the of the cell. And since not all direct dependencies are the part of the formula, we need to filter this. So we check if the affected has the direct dependency. And if it does, then we increase the in order direct dependency count, cell count, like this. So this is how we construct the in-degree map. Okay, so now we need to find the starting point of the processing. And remember from slides, the starting point of the processing is the element with the in-degree 0. So this is the A1. Now we need to go through the in-degree map. So for this, we're gonna use key and value of the object entries in degree. And if the value equals to 0, then we're going to push the value to the queue. So the queue is basically the starting nodes where we start the processing. So queue push the key. Okay, so now we have the queue where we need to start the processing. So let me hide the object entry for now. Okay. Now let's create another array, which we will call order. That's essentially the array which will contain ordered IDs that we're gonna process later. Okay. Let's now find the node that has the 0 in degrees. Start. And then we're going to take... Oh, actually, we already done it. So it's inside the queue. So now we're going to process our queue. For const item cell of the queue. And the next step is the following. So now we have the in-degree map. We're going to go through the reverse dependencies. So here, if we go back, so we need to get the reverse dependencies. And once we get the reverse dependencies and we process the node, we reduce the in-degree count. So for A1, because it already has in-degree 0, we're going to add this A1 to the ordering. So here we check if in degree cell equals to 0, then we push the order. Order push cell. And here, let's type the array properly. So we use array of the cell ID. And the same thing here. And then we say that the key is actually cell ID. All right, so we push to the cell, and now we need to fetch the reverse dependencies. So we're going to loop through the reverse dependencies, reverse dep of this get reverse dependency of the cell. So now we check if the affected has the reverse dependency. This means that we need to process this. So we reduce the in degree count of the dependency because we processed it, and we're gonna add if in degree reverse dep equals to 0. This means that it's our next point that we need to process, and we update our queue. We do the push, reverse dependency. So first we process A1, then we get the reverse dependency, which will be B1, and we process B1, and once we process it, we reduce the in degree of the B1 and push it to the queue for the processing, and the next iteration it will process C1. Okay, now this will construct the ordering. So at the end we'll get the order of the elements. So, but last thing that we need to be to handle. So first of all, if the in degree, so if any element inside the in degree map has the non-zero value, this means that this node has a loop. So we haven't resolved all the graph. So if any node in the in degree has a 0, then we need to add it as a cyclic dependency. So here, let's create another variable called cyclic. So we're going to extract the cyclic dependencies. And in order to understand if we have the cyclic dependencies or not, we can just compare the size of the affected to the ordered. So if the order array has the less elements, that means that there is some issue with the cyclic dependencies. If affected cell size less than order length, then we're going to check for cyclic dependencies. Now we loop through the in degree map again. Const key value of in degree. And now we push the cyclic dependency. Oh, we haven't checked anything yet, so one sec. If value equals more than 0, then this means that it's a cyclic dependency, and we need to push the value inside. So this will return the this will get us the cyclic. And the last step is to return the topological order algorithm will return the cyclic dependencies and the correct order of the processing. So we return order and the cyclic. And the cyclic, it's actually should be the cell ID array. So let's also cast it as a cell ID array. Still complaining. Let's see why. Okay. So cyclic is actually the set in our current typing. So let's use set and push the cyclic here. All right. So we've done the topological ordering now, but we're not executing this yet. So to test the things, we have a few examples here that we can check. So first of all, let's execute the engine and set the raw values to this engine, and then do a few console log statements. So here, if we modify A1, so this means that we need to process A1, B1, and C1 because B1 and C1 has dependencies on A1. If we modify B1, then we just process B1 and C1. And if we modify C1, we just process C1. That's the logic. So let's execute this and see if it works. and it doesn't work. Let's see why. Maybe the reason is, oh, affected from, 1 sec. We have the test method exposed. Maybe it's empty. Affected from, cell ID, and okay, here we have an issue. If the affected doesn't have the dependency, then we need to push this. So let's verify. Let's run again. Okay. So for C1, I feel like there is a logic miss here. So we should technically include A1 as the process set. Let's see. So here we call the affected from, and we get our start position, and we create a new set, and then we initialize the, okay, here we need to initialize the set with the start. So if you run it again, yep, now it works correctly. So we get the affected cells calculated correctly. So now let's check the topological ordering, how it works. So here we execute the tests. So we calculate the affected from A1. It will return A1, B1, and C1 sets. And then we do the topological ordering, and it should actually return A1 and B1 because we already because it's just a natural order that we have, and its cyclic dependency should be empty. So let's execute this, run. And the topo order is A1, B1, and C1, which is correct, and the cyclic dependency is 0. Let's execute a more complex test case. Here we have the circular reference. Oops. So let's uncomment this. Let's also comment this out. And comment this out as well. So here, if we try to calculate the, we want to see that the topological ordering will detect the cycle and show us that D1 and E1 are in cycle. So we run the test and see nothing else is outputted. So let's verify why it doesn't work. So this means that let's see. Let's first check the affected from, that it's calculated the affected from correctly. Console log affected. Run. So D1 and E1 are processed. So this means that at least this is a correct thing. And then let's jump to the topo sort algorithm. Let's verify that our in degree are constructed correctly. So first log the in degree. They should all both have 1. So the D1 has the, 1 sec. Let's go with it again, just for. Okay, so let's look what we are outputting. So this thing, let's comment this out for now. And execute again. So these are the sets in degree. And they look correct. So D1 is 1 and E1 is 1. And if we look in our code, so in degree is constructed correctly. And here we go through the in degrees. So if value is, so we pass to the queue, so the queue will be empty this is expected. And if the queue, so the whole thing will be amended, so we're not executing anything. And here, if the affected size is less than order length, let's check. The affected size will be 2, and the order will be empty. Oh, that's incorrect. So let's also change this condition. Let's just actually remove it to test if our assumption is correct. And execute again. And let's output the result again here. Yeah, so now the cyclic dependencies are detected. So it's D1 and E1. And this means that our execution is correct. Congratulations on completing the topological ordering. So do we have any questions on the Khan algorithm? Yes.
What would you expect the time budget to implement something like this Google Docs in an interview would be?
2 hours. And ideally, you should be given opportunity to have internet access and Google the algorithm, because you may know about the topological sorting, but it will not be on your top of the mind unless you're trained lead code a lot. Okay, so now we've done the topological ordering. And one note about this problem. This is like staff plus problem. You will not be asked to implement the full problem on the senior engineer interview. So these are like very complex problems that will take a lot of time. And also, you're also not expected to implement the full problem itself. So here we're kind of doing the more complex version where you do the engine and the UX. So that's the thing. Okay, so we've done the topological sorting. So what is the next step? So here what we've done so far. So the dependency ordering, the topological ordering, and now we need to evaluate the expression. Finally, we're almost done. So here how we're evaluating the single cell. We have our RPN notation for the cell. Then we feed it to the eval RPN function that is provided to us. And then this eval RPN function returns the string, basically the evaluated string. So the eval RPN function takes the RPN notation and resolve. Resolve methods provide, it's basically the callback that accepts an ID, and we need to access our store to resolve the cell ID reference. That's how this eval RPN can get the actual value from the engine. And then we get the computer result. Yeah, let's go ahead and implement the evaluation. So open the folder 60 Google Sheet eval and open the table engine. And here you will find the step 1. So build the evaluation pipeline. So first of all, we need to get the raw expression for the single cell. So to get that, we access our state and get, actually we can use just get raw ID. Now we need to check if row starts with formula, then this means that we just need to return the raw value, and it will be the actual value. And if it's not the case, then we need to get the compiled properties. So we fetch the compiled RPN notation, get compiled, then we get the pass the ID, So here we have the get. And now we have a few cases. So the first case, if the compiled, it has an error. So if compiled has an error, if compiled, let's see, if error in compiled, then we need to return error value. And if the compiled is null, then let's return just an empty string. Okay, so now we checked if there is an error in compiled, we return an error. If otherwise, we need to get our RPN from the compiled. And now we need to evaluate the RPN. So we create a constant value, eval RPN. We pass our, let's import this. And we pass the RPN, and then when we receive the reference ID, we access our engine and get the value for the reference ID. Okay, so now when we get the value, we just return it. That's the single, that's basically what we need. And we can basically do this, return eval RPN. That's how the single cell is evaluated. So now let's glue it together. So in our setRow method, let's use the eval cell and evaluate a single cell. Here we just use the row, but instead we're gonna set the value to this eval cell ID. That's our method, and this will set the value. And we still passing the just one ID and changed, so this will be changed soon when we start to recompute the dependencies. Okay, let's run a few tests. Here, let's initiate our engine. Let's set the row values A1 and 10 and B1 as 20. And now let's get the value. So A1 is 10, which works correctly. Now let's set the row, and this should trigger the evaluation. So here we have a C1, and C1 equals A1 plus B1. So A1 and B1 are static values, so we don't need the full recomputation, so our test should work, and the eval cell should be evaluated as 30. Let's call it, and it's 30. This means that our formula works correctly. Let's run a few more examples. Run. Here it's 60, so expected value is 60. And now let's check the division by 0. So this should be invalid value. And here the even value. It actually should be error. Okay, let's see why it's not outputting the error. Let's see. Let's open the file, the eval cell. Eval RPN. Return value, and let's see what is the value that we're passing. So console log value, and the way we can check if the number is none, value plus, then we return an error. Otherwise, we return the value. Let's test this. Run. Now we return an error as expected. And if we use the plain value and try to get the value, so it should be hello. And if we use invalid formula, it should be error as well. It's error. So our evaluation works as expected. All right, so now we've done the evaluation. The last step is recomputing the whole thing. So we've done the topological sorting. So we marked all the loops, and now we have the order. So we can go through the cell in order and eval every cell. So let's do this. Any questions before I proceed to the last step of the engine implementation? Okay, let's complete the recomputation pipeline. So the recompute from is always starts from the cell that we just edited. So we get all the cells, and now we're calling the affected from method that we implemented in the past. We start with this with the start cell. Now we want to get our cyclic dependencies and the order dependencies from the topological sorting. Topo sort, and then the affected. Good. So now we have the cyclic dependencies and their order, and we can change the array. By default, it will be empty. Okay, so now we need to iterate over the cyclic dependencies and set the value of the cyclic dependencies to cycle. So we just mark them, the cells are invalid. So we loop through the cyclic dependencies. Cell of the cyclic, and then we set the value, cell, and we have the constant called cycle. Okay? The next step is to go through the order array. So for cell of the order, and now we can set the value. So this val set. Let's calculate the value first. Const value. And now we need to evaluate the cell. So we call this eval cell, pass the cell. The eval cell will give us the new value, and we just assign this new value. This value, eval cell value. Set cell, and this is the value. Whew. Okay. We also want to make sure that the cell is not present in its cyclic. So let's verify this. If also cyclic has the cell, Then we set the value. Okay. Oh. Now we have all the changed cells. So here, what we can do, so basically all the cyclic and the order, it's all our changed cells. So we can merge the cycle and the order. So for that, we create a new array changed. And then we call array from. And then we pass the new set. And then we merge the cyclic. Now, actually, let's convert the order into the set. New set, and we pass the order array. And then we can create a new changed set that we can construct with the order set. Then we can merge. Do we have the merge method on the? Is it the union? Okay, that's the union. So we can call the order it set. So we can call our order it set plus the cyclic. So that's the changed. Why you're complaining? Expect just one. Ah, okay, makes sense. So order is set here. That's our changed array. And let's return it. Return changed equals to array from changed. Let's verify. The cell itself should have the cell ID inside. And our union set will also have the S set of cell ID. And let's see why it's complaining. Oh, it's because it just returns changed. Return changed.
Just got it changed up there.
Yeah, we have it in the top. Array from. Whew. So that should be it for recompute. Let's see if it works. So we have a few examples here. We create a table engine. So let's evaluate a few examples. If we click run, then it should correctly evaluate the numbers. Run 10, 20, 25, and that's the expected output. So let's do a few more examples. Let's click run, and 50, 100, 105 also correctly evaluated. All right, I think we're done with this one. So now we are recomputing the whole set of the values, and engine now stores all the correct values. And the last part is the nicest part. We now need to build the UX. Okay, before we start building UX, any questions in the group or in the chat?
Could you move your cup to the other side?
This one?
Yes.
Okay.
And we are also due for a break if that's cool, unless there's questions.
Can we just take like a 5-minute breather?
Yeah.
Okay.
On break for
Sergey.
All right, guys, last step. So we went through the whole workshop. We implemented the Google Sheet engine. Now it's time to build the UX for that. So in order to build the UX, so first we're going to build the cell component, which will represent a single cell. Then we're going to prepare the headers, prepare the rows, and handle all the events. I'll show you how can we purposely bypass the React update lifecycle in order to preserve the performance of the application. So in this case, it will be actually the correct way to do that. And because we don't have a Redux to efficiently update all this single cells, if we set up the state, all the cells will be rendered. So we want to avoid this issue by bypassing the React lifecycle, and you will see how we do this. Okay, so first of all, let's jump to the code and open the IDE, and here is our Google Sheet UX problem. So we're gonna implement it in React, and here's the a few variables that we already have. So first of all, we have the columns that we have that will act as headers. So as you can see, we already have the array set up. Now we have the table column, which basically a type, the string type, which represents all possible table columns. This is needed to construct the cell ID. And here we have the utility function, which is called from the cell reference. Essentially, it takes the string cell ID, and cell ID is consistent of the heading letter and the number. So, and it extracts the first letter as a column, and then constructs the number, the row, and it puts the row in column. Then we have the reverse method that that constructs the cell reference from the row and column instead. And we have the utility function called getCell method element that returns the specific cell for the defined query element. So this is just the basic methods that don't have much logic but save a little time for us. And also we'll use the empty symbol to represent the most top left corner on the Google Sheet. So let me show you what it does. So if you open the Google Sheet UX, you will see there is a reference example in React. Here's our Google Sheet. So this empty cell, it's what this empty symbol represent. Okay. Then we set up the maximum number of rows, which we'll set to 50 for this example, and the constant with all the table columns. Then we initiate our table engine, and we pre-populate the table engine with some values so we can test the things once we complete the exercise. Also, we have the table properties. The table itself, the cell itself only accepts the column, the row, and its value. And there is a utility class called resize class that we're going to use later in order to enable the column resizing. That's it. So that's our scaffolding. So our first step will be to implement the cell component. So let's do this. The cell itself will be relatively easy. So we're going to return the div element with the value inside. Okay. So actually, no, this is correct. And each cell will have its own column and row. So we'll create a few data attributes. The first one will be data row, which will be equal to our row. And then the data column, which will be equal to our column. And a few things before we continue. So because we're trying to build a kind of accessible spreadsheet using the divs, this means that we need to assign the correct role. So in this case, we need to check if the row equals to 0. This means that this cell will act as a row, as a column header. So let's see. Let's create a variable called role. So if column equals to 0, if the row equals to 0, then our role will be column header. Else, if the column equals to 0, actually equals to empty, because the first column will be empty. Then our role will be the row header. Otherwise, the role will be equal to grid cell. So let me explain what is the column header and what is the row header. So the column header, it's this one. So this are our column headers. So in the row header, it's what we have the number of the row. This is the row header, and the rest of the content represents this cell value or grid cell. That's how we properly assign the correct role. So now we assign the role equals to role. Now our div will have the correct role. So the last bit which is remaining is assign the correct class name. So we already have some default styles available. So essentially the grid cell just have one box shadow to mimic the borders, and the grid header will have some background color, which basically separated from the main cell. So let's assign the proper class name. Here we use the css.grid cell. So, and because we have two classes, we can have either the row header, we can have either the header or the grid cell. So let's also create a variable to represent this. So if role equals to the grid cell, then we assign the class grid cell. Otherwise, it will be just grid header. And we pass this class name inside. And now we have our cell component almost implemented. So what are the remaining things that we need to have? So I'll show you the trick, but first let's render the cells. So here, let's create our header rows. So, essentially, the header row is a single row on the spreadsheet, and we need to map through all our table columns, which are just the letters. So here we assign, we take the column and call column index. And then we return div element. Oh, actually, we return the cell, sorry. So we return the cell, we pass the row which will be equal to 0. And this, the cell and the column will be equals to col. And let's see why TypeScript is complaining. It's because we haven't closed the tag yet. And the value of the cell will be equals to the column itself. Okay. So let's see why it's complaining. It's because the value can be symbol. So in this case, what we do, if column equals to empty, then we pass empty string. Otherwise, it's just column. That will be our header row. So it's still complaining. So let's see why. Okay, let's force it to be string. So TypeScript is happy. Yeah, now TypeScript is happy. Let's move some properties to the next line so you can see it. And let's also hide the menu. So now we have the header rows. So let's show them. Here we already have the header rows and the body rows. So now if I try to render the header rows, we should be able to see at least one row. So let's go back and use the student React file. And here is our row, which doesn't seem to be correct. That's because we're rendering the body rows yet. So let's also fix that as well. So now we're taking our body rows and let's render them as well. So we go over, we're creating an array of the size 50, and then we map each row. And because we're now starting, so the starting index should be 1 because the first header was 0. We're adding 1 to each index. Okay, so now we map our table columns. Map column index. And then we need to return the cell. Okay, so now we're passing the row, which is the, let's call it row index here. Okay, it's already here. So row ID. Then we pass in the column, which is the column, and then the value. And we only initiate the value if the column is the first one, which is has the number there. So if the column is empty, then we use the row ID as the value. Row ID. Otherwise, it's just empty string. Okay. I feel like a few things I'm missing, but this should be it. Let's verify now. So we rendered the header rows and the body rows. So if we refresh the page, yeah, it's almost there. So let's now verify that we have the stylings assigned. So we take our elements. So we have all the rows and we have the grid, but the grid doesn't have the proper styling. So let's create a CSS grid. Update the styles. So we have our grid. Let's display it as a grid. And then let's grid template. Let's do the grid template columns. So we have 26, I think, columns, and let's initialize it as one fraction. And if we update, I will have more columns, sorry.
7.
Is it 28?
27, because you have a blank.
Oh yeah, 27. So updating. So now we kind of have our table, kind of. So, but as you can see, the cells are not editable, and they're very small. So it would be great to be able to increase the column size. What we can do, So first of all, we have the secret life hack. How can we edit any? How can we enable editing on any element? So this is called content editable attribute. So we're gonna take the cell and pass the content editable attribute inside, and it's gonna be true. And we're also gonna tell React, hey React, suppress the warning, so I know what I'm doing. Update. So now I can type some value inside, and we also want to be able to resize the columns. So apparently in CSS there are some there is a default style that we can use. So this is called resize. Resize vertical, resize horizontal. So in this case, what we can do, we already have the resize class constant, and based on the role, it fetches the correct class. So let's also get this class name, const resize class name equals to resize class, and then the role. And here we need to set the role as a set of the column header. That's just to make TypeScript happy. Now we get the resize class name, which we can assign. Let's do the CX tool. But let's use the CX tool to merge the class names, CX class name and resize class name. Okay. Let's see if it works. Refresh. And now, yeah, see? We can now resize our column horizontally and vertically. Okay, one thing to note here. So, as you noticed, we kind of bypassed the React update cycle by pre-generating the rows and the headers. So this is because if you place these calculations inside the Google Sheet itself, then every time you update the state, and if you have any dependencies, you have to regenerate these values again. So in order to avoid this, we are purposely bypassing the React lifecycle, pre-generating the UI, and rendering as a static constants. And we are not going to use the standard state in this case. We're going to use the engine state and manually update the rows. This is because React doesn't play well with when it comes to large chunks of the cells without Redux. Redux allows us to just update a single cell and avoid the re-rendering the whole thing. But because we're on interview and we don't have any frameworks available to us, so we have to bypass this by showing our knowledge. Okay, so now we need to enable the formula parsing. And for this, we need to handle the cell change. So we can register the single event on the table somewhere here, and it's already here. So on blue capture and on focus capture. So when we focus on the element, what we want to do, we want to show the row formula. When we blur from the element, so this means that we are done working with the element, we need to recompute. That's how both of these handlers work. Okay, so now let's update the method which is called update cell view. So what it does, it extracts the value from the engine and sets the value. So now, first we need to get the element from the get the element from the page. So for this, we first get the row and column from our reference that we receive. Then we query the element. Element equals to document. Oh, actually, we have the element. So we call it, what's the name of this function that we have? Yes, it's called getCellElement. Let's use this one here. GetCellElement. We get the ID of the element. Now, if there is now such element, we just return. And why it's complaining? Oh, okay. We need to pass row and column. Okay, so now we need to check if the currently selected element is the current element, then we need to show the row value or the formula of this element. Then we extract the row value from the engine get row, and then we access ID. And then we set the text content of the element to raw, like this. Otherwise, if it's not the case, then we return the computed value instead. So let's inline this. That's how the update cell view behaves. Okay, now let's handle the focus. So inside the focus, forget our target element, which is currently focused. So we can get the row and column values. Row and column. And then we can, okay, first let's verify that it's HTML element. So if target instance of HTML element and target dataset row and target dataset column. Then we get the row and column equals to target, oh actually, row and column target dataset row, and we convert the row to the number. And we do not convert column to the number because it's a string. So let's remove plus. Now we get our row and column. Now we need to query the element. Actually, so when we focus on the element, so we get the row, and then we need to set to the row value instead, sorry. And then we can actually call update cell view and pass the, so update cell view takes the, and pass the 2-cell reference there. And the column, let's convert it as cell ID. Why are you complaining? Okay, let's ignore this warning. Just let's check if the focusing works. So when we focus on the element, it should display the full formula of the element. So if we display A1 plus A5, oh sorry, let's actually initialize it. Let's refresh it. So let's initialize A1 and B. And then let's use A1 plus B2.
B1.
Oh yeah, B1. And yeah, nothing happens because once we focus out, we haven't implemented the blur method. So, and that makes sense. So now we also need to implement the handle cell change method that happens when we blur from the element. Let's do this. Now we have the handle cell change, and we check if the target instance of HTML element and the target dataset row and the target dataset column. That's our check. Now we want to fetch the row and column to build the cell ID. So we fetch, let's copy the code from here. We already have it. So when we, let's build the reference. So const ID equals to cell reference, row and column. Okay. So now we have the row content inside the cell. We want to update the engine. So for this, we need to get the content of the cell. And in order to get it, we need to query the element first. Oh, it's actually target already. So we can get the target dot text content. That will be our raw content. Then we call the engine set row, and then we set the row value of the cell. So the set row gives us the changed cells. So we have the changed cell. Now we also need to update the current cell. So we call the update cell view and pass the ID. And we loop through the changed cells. So here we have the cell of changed. And then we update each cell as well. That's how we bypass the React lifecycle. And here it should be like this, changed. Okay. I think if we try to run it, it will work. So let's see. So now we have the A, and let's say it equals to 10. Now we have the B, it should also equal to 10. Now the A2 will equals to A1. Did we refresh the page, by the way? And let's refresh the page first, sorry, to make sure that the code is updated. So 10, 10, formula, A1 plus B1. And then if we focus out, nothing happens. Let's see why. There is a weird, let's see, maybe okay, we are not adding the key property, but it's not critical. All right, so let's see what's going on. So on the handle cell change, when we blur, we should execute. Let's see if it happens. Debugger, refresh. 10. So the event is not executing in this case. It seems like. Let's open sources. Oh, we have the breakpoints disabled, so let's see. A1 plus B1, and then we focus out. Okay, it works. So let's see why it doesn't work. So we have the data set, and it has the column and row. We go inside. Now we cast we compute the cell reference, which is A2, and then we get the context. Then we set row, and then we have the changed, which is the H2, which is correct. And then we update the cell view. And inside the cell view, let's see what's happening here. We extract the row and the column, which is correct. Now we try to fetch the element, and the element is null. And this means that we haven't set the row and column properly. Let's check this. Let's check the code. Here, we have the data column property where we set the column, and data row where we set the row. And let's see what the actual values we have here. So let's disable the debugger, let it go, and let's inspect the DOM. So we have the data row, but I don't see the data column property. Okay, we have this A, B, C, and for some reason it wasn't, the query didn't work. Let's check it.
Look at your real rows, yeah. Yeah.
Okay, now we have the row header. And this is the value, the grid cell. So the grid cell has the row and the data column. So technically it should work, but I've noticed that, yeah, here's the issue. We used a col, not a column. So let's refresh this. And do it again. Oh, so now we're showing the predefined values. So I know, let's do it again. So here we predefine the values, but we haven't, in the use effect, we haven't updated the cell view for them. Let's update the, okay, let's actually remove this for now. Okay, so refresh. 10, 10, formula open, A1 plus B1, focus out. 20, yes, now it works. So let's make some, yep.
Click back into A2.
Now we see the formula, yeah. Congrats. So what if we create a cycle? So for instance, we have the cell, which will depend on the B1, B2, or it's actually B4, sorry. B4, and then we have a cell that will depend on A4. So it should be cycle. Both values updated automatically. And let's make some more complex formula. Let's remove this. So here we have 10. So let's make the also B as 10. Now A1 plus multiplied by on B B1, and let's make B1 also depend on some cell to verify that the chaining works. So the C equals to 100, and the B1 will equal to C1 multiplied by 2 plus 50, for instance. And focus out and see all the dependency updated, and let's update the C value and see if the two values are updated now. All values updated. That's the spreadsheet. And the thing is, The engine itself in a Google Sheet is very similar. It just has more formulas and rules. And instead of the DOM rendering, they use the canvas as the technology because the GPU rendering is much faster. But overall, the idea of the spreadsheet works like this. Congratulations, we've completed the spreadsheet problem. And I know that was a hard one. And before we finalize the workshop, do we have any questions?
Can it catch transitive cyclic?
Transitive what?
Like, so A relies on B, B relies on C, C relies on A.
See, can you repeat this?
So A1 equals B1,
So A1 will equal B1, okay?
B1 equals C1, or
B1,
B1 equals C1, and C1 equals A1. Nice.
yeah,
Okay.
cool. So let's go back to our slides. So recap, we created a cell component. We prepared the header rows and the body rows statically to avoid re-rendering them every time we change the state. The engine will own the state, and we bypassing the React states for the performance benefits. And then we render the table, and then we handle the focus and the blur event. And then when we focus on the formula, we show the row value. When we focus out from the formula, we show the other value. And that's me throughout the whole workshop. Yeah, guys, it was very hard. I didn't expect that it will be so hard to code for 12 hours in 2 days. So yeah, I hope you liked the workshop, and the complexity of the problem was good enough, and it wasn't too easy. So yeah, let's finalize the workshop, and thanks everyone for watching, for all the comments on the work stream. If you want to learn more about system design, I have the course on the for the front-end system design on the Frontend Masters, and I also have the YouTube channel where you can also see the some other videos on the system design. Thanks a lot, everyone, and yeah, wrapping up.
Yeah, we'll give like a minute for any final questions. Seen a lot of thank yous in chat, so that's cool. But if you have any final questions, this is your last chance. It's your final warning.
And if you're an interviewer, please don't ask these questions on interview.
Wow. So,
Should we mention that we left some problems aside? So actually, there is a bonus section that the people can complete with extra problems in the repository as a homework.
All right, well, I'm not seeing any other questions, so congrats. Good job.
Yeah.
Oh, wait. One question just came in. For senior or mid-level interviews, is hard and medium the right questions to study?
To be honest, with the current environment, the expectations are very high even for juniors. So now you're expected to solve such complex problems even on a junior level. So I would try to actually work through all these problems, because you're competing with in a bad market where you have more supply than the positions. So yeah, unfortunately, that's the reality we have to face right now. So, and make sure you are able to solve all the problems, even if you're a middle level engineer or junior engineer. That's the truth.
All right, well, thanks everybody for joining us. We will cut there.
All right.